score booster series that has been specially designed for you so that you will be able to revise the major topics that have been repeated consistently in UPSC in the past 10 years. They are directly asked like what is happening in this case. One is benefiting, or they will give you examples like find out which is parasitism, which of these relation indicates mutualism. There is this one stone that is holding everything together, right? One stone that is holding everything together. That is why they're called Keystone species, the one species that is holding everything together. What do we call it? Amazon of Europe, spreading across 5 countries. How many countries? 5 countries, please remember that. Austria, Slovenia, then we have Croatia, Hungary and Serbia. Clear? 3 rivers are involved. 3 rivers are involved across 700 kilometer stretch, that is Mura, Drava and Danube. Mura, Drava and Danube. The name is Patna, but it is in UP, not Bihar. This is where UPSC will confuse you. Hello everyone, welcome back to your favorite channel Drishti IAS, and we meet again for our score booster series, and today we've come up with environment subject. Yes, score booster series that has been specially designed for you so that you will be able to revise the major topics that have been repeated consistently in UPSC in the past 10 years. So what we've done is we've analyzed past 10 years papers so you don't have to do that, and we've compiled some topics that have been consistently asked in the past 10 years. All right, so that means they're favorites of UPSC and naturally they should be your favorite too. Yes, is that true? All right, so this is what Score Booster series is all about, and this will be very helpful for you for your prelims of 2026. So make sure you revise through these. That will give you a proper insight of what topics are consistently asked in UPSC and where you have to lie your attention on. Yeah? All right, so beginning with our series of environment today, and we will be talking about various aspects of environment that have been consistently asked, and then we will also solve a few questions, right? Through the questions, you'll be able to see how questions can be framed from the same topics. All right. So shall we start? Are you all ready? Yes. Yes. Show me some energy. Are you all ready? All right. Let's begin our session. And we're starting with very basic because we're talking about environment. We'll try to understand what environment is, what ecology is, how these terms are used, because terminology plays a very important role in environment subject. Please remember that. In general terms, we use anything and everything interchangeably, very easily, right? But in terms of environment technicality, you have to pay special attention to the terms. Okay, so we'll be doing that. That's why, first of all, let's understand what environment is, what ecology is, how they're all different, and there are many such terms. Yeah? Okay? All right, so we're starting with environment, that is ecology basics. We're trying to understand the very basics of ecology, like we'll understand what environment is. In basic terms, always we say that what is environment? Environment is nothing but your surrounding. Yes, environment is nothing but your surrounding. Anything and everything that you are surrounded with is environment. That is your surrounding. Yes, can we say that? Exactly. So if everything and anything that surrounds you is environment, that means the room that you're sitting in is your environment. When you step outside, your road, your infrastructure, that is your environment, right? Anywhere and everywhere you go, that will become your environment. For Earth's perspective also, whatever surrounds Earth, that is its environment, naturally. Yes? What surrounds Earth? Just think about it. What surrounds Earth? In the frame of environment, we see 3 elements that are taking care of Earth, or formulating Earth, basically the environment of it. That is lithosphere. Yeah. Can you see lithosphere? That is the land of Earth, the land itself, the land part of Earth. Yes. We see biosphere. Yeah. The entire biosphere that we see around the earth, comprising of the earth, we see lithosphere, we see water resources, we see air resources. All these things basically compile all together into biosphere, which is all together compiling into Earth's atmosphere as well. Yes, Earth's environment as well. Clear? Yeah. Lithosphere, atmosphere, hydrosphere. We have all these. Yeah. This is what comprises of all the genesis. Like, how is the Earth divided? First of all, we have multiple components here. We have sun, the source of energy, the ultimate source of energy. Yes, we have sun, the ultimate source of energy. We have atmosphere, that is the envelope of gas that we have. Then we have cryosphere, frozen water part. We have biosphere, supporting all life. We have hydrosphere, that is water on the surface, right? All these things. Lithosphere, that is land. You know, all these things comprising all together are the 4 interconnected spheres of Earth, right? These are what will constitute into environment for Earth. Okay, they will frame an environment for Earth. How will they come up with an environment for Earth? That we will see. Okay, that we will see. But first tell me, do you understand all these 4 aspects, all these 4 spheres of Earth? Lithosphere, cryosphere, hydrosphere. Yes, do you understand that? Hydrosphere or atmosphere? Yeah. Okay, exactly. Now see, we have 3 terms, that is environment, ecology and ecosystem. Okay, we'll be talking about these 3 terms. Environment, we'll talk about environment, we'll talk about ecology, and we'll talk about ecosystem. Okay, what are these 3 things? Let's try to understand first, then we will individually go to their differences. First of all, talking about environment. What is environment? What is environment? Just as we discussed right now, anything surrounding you physically. Physically, you are across anything. There's a plant, that is your environment. There's a chair, that constitutes your environment. There are walls, that constitute your environment, right? So for Earth also, anything that is physically present there, surrounding is environment. Yes, very simple. A blanket cover, physical surrounding or conditions. Yeah, simply what we will call this? Physical surrounding or conditions. Can we do that? Yes? Yeah? Would you care to give some examples of the physical surrounding or conditions? Person, animal, plant, anything. Okay. When we talk about ecology, what do we say? Everybody included here, right? People, plants, animals, etc. Yeah, all of them are interacting with each other. Are we interacting with our environment? You're sitting in a room, you're looking at something because there is light, right? Because there is light, you are interacting with the light. Because you're sitting on the bed, you're interacting with the bed. Because you're sitting on table or chair, you're interacting with it, right? There is interaction between the environment and the individual, right? Ecology is basically the study. Okay, what is ecology? Ecology is basically a study. A study of what? The interaction between these. The interaction of an organism, it can be anything, with its environment. With environment. When you interact with your environment, what kind of interaction it is, what happens, what is the cause of interaction, when we study that, it becomes ecology. Is that clear? Yes, that becomes ecology, right? This is in physical environment. Please remember that. We are talking in physical environment. Yes, in the physical environment, when you are interacting with your environment, that becomes, and the study of that becomes ecology. Yeah? Is that clear? Yeah. So organisms are interacting with each other. Okay. Organisms are interacting with each other in their physical environment. What is ecosystem then? Yeah. What is ecosystem? Ecosystem is a functional unit. Yeah. A functional unit, like for example, your room where you're staying, you're able to eat food, you're able to study, you're able to sleep, you're able to live your life basically. interacting with all the elements of your environment. Yeah, that room becomes your ecosystem, right? Like we build a library in the house. Why? Because we want our refuse. Like we build a playroom in the house, like putting a PlayStation in there, having our own time. That becomes our ecosystem, right? Exactly. So this is also a functional unit where organisms are interacting with each other, interacting with the environment. That particular unit, that is functional. Why is it functional? Because it works for everybody, right? It works for everybody, that this function goes on. It is not coming to a deadly halt because it is working, right? It is functional. And that functional unit where organisms are interacting with each other or the environment is called your what? Ecosystem. Is that clear? So basically this is a functional unit where living organisms interact with each other or non-living organisms as well, right? So living organisms are interacting with each other or non-living entities as well. That's fine. Or the environment in general. Just take a look at these three terms and tell me, is this clear? Do you understand the three terms? Is there any doubt or query? This is the very basic. This is the basic of the subject. You need to know these so that you're able to move forward and understand better. Is this clear? Yes. Absolutely clear. All right. Let's see the differences then. Definitions we've already seen. What is the nature? In terms of environment, we see physical area. It is the where of the life. Where are you doing this? In this particular environment. Okay. Ecology is the discipline of how and why of life. Like, how are you interacting? Why are you interacting? We study that. How are you interacting? And why do you want to interact? Why can't you just sit idle? That is studied in ecology. In environment, it is the function unit. It is just a system, right? The system whom we are studying. It is just a system, nothing else. We're not trying to observe it. We're not trying to see anything. It is the system that is functional and we're just looking at it like, okay, good system. That's all. Yeah. Components. Environment includes external factors like biotic, abiotic, whatever is affecting the organism. Ecology focuses on relationship because they're trying to study something. So they have to see patterns, they have to see communities, they have to see relations. That's how it works. For ecosystem, they specifically focus on flow of energy. They see how the system is functional, right? They want to see how it is working. What is making it work? How is the energy flowing from one organism to another? Because energy, as we know, can neither be created nor be destroyed. So transfer of energy is happening. That is how the system is functional. How is that happening? They just want to observe the function. That's all. How it is working. Okay. Yeah. Scope. Environment includes anything and everything. Anything and everything. Ecology. It is just academic and analytical power. Ecosystem. Site specific because you need a system. Like you're studying a pond. You're studying a river. You're studying an aquarium. That is your limited zone. That is where you will find your nemesis. Clear? Is that clear? Yes? Yeah. So example for environment, any city, marine environment, anything you can take. Ecology, like we're studying how there used to be some migration, like migratory birds used to come to this coast, but they're not coming. Recently, the oyster study has happened, right? After many years, the oysters have come back, right? Why? Because earlier they were hunted down or the temperature was not fine, but now they're coming back. Yes, olive ridley turtles come. They come for a certain environment. When we study that, why they are coming here, why this motion, how are they coming, that is ecology for you. Yeah. And as for ecosystem example, a coral reef. Very simple example. You take a small pond also. That is also your ecosystem. Clear? Yes? Is that absolutely clear? Let's look at its stages. Let's look at its levels. Like, yeah, there is one individual. Then when they gather around, it becomes a population. Okay, there's one person, a lot of people come, we call it population. Now there is population. With that population, different kinds of population. Population kind A, kind B, kind C, kind D, all of them come together. Right? So they form a community. What do they form? They form a community. When that community starts living together, right, interacting with each other, sustaining with each other, that becomes an ecosystem. Right? When multiple ecosystems actually interact with each other, that becomes a biome. Yeah? When that is happening around different areas, it becomes a biosphere and sustains life. Yeah? Yes. They're interacting with each other, they're interacting with the entire structure, and even if they're not interacting, they're coexisting at least. That becomes a biosphere that has lithosphere, hydrosphere, cryosphere, atmosphere, all the elements into it. Right? Yeah. Do you understand the difference? Do you understand the levels? Yes? Exactly. That is your level of ecological organization. Clear? Yeah. So when they are interacting with each other in the environment, when they are interacting with each other, we saw the energy transfer happens, right? How does that happen? How does that energy transfer happen? For that, we have two concepts, okay? For that energy transfer, we have two concepts, that is food chain and food web, okay? Eating and being eaten, that is how energy transfers. How? Eating and being eaten. Why? Sun is the ultimate source of energy, right? So let's say I got 100 units of energy from sun. Okay, I got 100 units of energy from sun. Now, when I have this energy, I am going to consume that energy and make sure that I do something while eating, while running, while living. I will try to consume that energy. But I'm putting that energy somewhere, right? I'm putting that energy somewhere, and that energy will revolve around. Let's say I put that energy into plantation. Okay, I planted this, I put my energy into this plantation. Now through this plantation, the energy will go to this sheep who will feed on this grass. Yeah, I put my energy in this grass. Now this sheep has fed on the grass and gained that energy. Yeah. Now, when a fox eats the sheep, that energy gets transferred into the fox. Yes? Yeah. When the fox gets eaten by a wolf, the energy gets transferred into the wolf. Yeah? And any further person, let's say a lion has come, lion will eat the wolf. Ultimately, lion will have the energy. When lion dies and gets buried into the earth will gain its energy back, and that will lead to more grass formation. Yes, that is how energy keeps transferring. Yes, do you see that? Yes, that is the transfer of energy. Now this transfer of energy is taking place in stages. What do we call those stages? Number one is primary consumer. This is primary consumer, secondary, and then tertiary. Yeah, very simple to understand. The one who ate first, the one who ate second, the one who ate third. That's it. Primary, secondary, and tertiary. Is that clear? Yes? That's how the energy gets transferred, and that is the chain. You see the chain here? That is our food chain. Clear? Yeah. Eat and be eaten. Eat and be eaten. Eat and be eaten. That's how it goes. Clear? Is that clear? Yes. That is our food chain. The other concept is food web. This is a bit complex. Not a very straight chain as we just saw. Why? Because it is not that sheep will only eat grass or only fox will eat the sheep. Right? Sheep can be eaten by any other animal as well. So it is the food for any other animal as well. So there is a cross connection. That cross connection generates the food web. Food web, that is that complexity that everybody is a food for anybody. right? There is a cross connection like you see here. Like you see here, interaction with the river, water lilies, green algae, the plants are interacting, fish is interacting, grasshopper, frog, snake, even the eagle, and everybody is interacting with each other. Yes? Yeah. Can grasshopper be eaten by eagle? Yes, of course it can be eaten by eagle. Can grasshopper be eaten by snake? Yes, it can be eaten by snake. Can grasshopper be eaten by frog? Yes, it can be eaten by frog. Right? So they are interconnected. They have multiple connections and multiple outlets. That generates a complex food web. You understand that? Not just animals, birds, we are including plants here. Everybody is included, and that is in general our food web. Is that clear? Yes? Do you understand that? Yes? Food chain and food web, just take a look at it. Just take a look at it and see food chain and food web. Yeah? Clear? All right. Now, while we see the differences between the two, naturally, they are more complex than that. Naturally, they have more complexity to themselves, because it is not just about the food, it is also about energy transfer, right? And while we are transferring energy, we have to make sure that it is getting utilized. And now while it is getting utilized, we are generating multiple segments, multiple kinds of ecosystems here. Yes? Yeah, that is food chain and food web for you. Is that clear? Absolutely clear. All right, then let's move forward. And we'll talk about the other factors included here. What kind of other factors are included here? That we have a comparison. This is a food chain. This is the food web. Yes? Very easy to understand. Direct food chain, direct connectivity. This is a food web, interconnectivity. Interconnectivity to multiple angles. Yes, is that clear? Yeah, the change is visible. Change is visible here. Exactly. So what are the differences between food chain and food web? Basic defined structure, single isolated straight line sequence of energy flow. For food web, we'll see network of intersecting overlapping structures. Operational unit, independent, simple pathway. In terms of food web, it is integrated, complex, right? Yeah. Trophic complexity, we'll see it is limited to stages, like 4 to 6 trophic levels will be there. Like grass, then sheep, then fox, then wolf, then maybe lion. That's it. That's where it ends. Maybe eagle can also be added. That's it. Other than that, there is no other chain. But in food web, there is complexity, so multiple chains are formed. So it is unlimited, right? Yeah. Ecosystem impact, if you see, if we follow a food chain, it promotes greater ecological fragility because it will collapse. The moment one element breaks down from that chain, that singular chain, the moment one element breaks down, the entire chain breaks down. So it is very easy to collapse. But in terms of food web, everybody has multiple options. So if one is eliminated, they will find another, right? So in food web, we see better, stable structures. Yes, greater ecological resilience. Clear? In terms of evolutionary advantage, we'll see it provides limited pathways, while food web gives capacity for adaptation for multiple angles. Sensitivity to disturbance, we'll see food chain highly vulnerable. Food web is very robust because it is very strong. Yes? Yeah. Predator dietary range, if we see, in food chain, consumer feeds on one specific lower organism. In food web, multiple. Yes? Yeah. This is the difference between food chain and food web. Is that clear? Yes? The very basic of it, food chain and food web, that we've tried to understand so that we see how energy flows and how complex it is in the environment to maintain that energy. Yes, it is a very complex structure. To understand that complexity, to understand the very basic of how environment is functioning, this was necessary. So do you understand that? Yes, is it clear? All right, let's move forward then. With that, Let's move forward and solve a question based on this. Food chain and food web, the whole concept. Let's solve a question on this, shall we? Yes? Yeah. You have a question on the screen. Try to read and solve. With reference to food chains in ecosystems, consider the following statements. Number 1, a food chain illustrates the order in which a chain of organisms feed upon each other. Second, food chains are found within the populations of a species. Third, a food chain illustrates the numbers of each organism which are eaten by others. Yeah. Okay, this is a practice question for you. This is a practice question for you. Do tell us the answer. Do tell us the answer. Okay. Yeah. Moving on. This entire complex structure leads us to ecological pyramid. Okay. The entire ecology comes into a pyramid. Two kinds of pyramid, upright and downright. Yeah. Inverted pyramid or upright pyramid. We have two kinds of pyramids. We'll take an example of one. The downward filtration is obviously clear from that. Clear? Yeah. So we have two kinds of pyramid. The base that starts here, primary structures, producer. Okay, grass, let's say grass. First of all, the grass is eaten by the sheep who have very high energy. That are primary consumers. Then they are eaten by secondary consumers, they get mid energy. Then they are eaten by the apex predator, that they get the lowest energy. So while we say that energy can neither be created nor be destroyed, then where is the energy going? Where is the energy going? Very good. The energy gets lost in the form of heat. In the form of heat, right? The heat that gets out, that leads to the loss of energy. Okay. And because of that, as we reach to the top tier, very limited energy is transferred there. Very limited energy is transferred there. Do you understand that? Yes. That is our ecological food pyramid, that how it gets transferred and very less energy gets transferred actually. Yes. This is our ecological food pyramid. Let's solve a question based on the ecosystem as well. Yeah, another question based on ecosystem. Let's solve that. Yeah. Read the question. Which one of the following is the best description of the term ecosystem? A community of organisms interacting with one another. That part of the earth which is inhabited by living organisms. C, a community of organisms together with the environment in which they live. D, the flora and fauna of a geographical area. Yeah. Okay. Solve that. Give me an answer very quickly. Give me an answer. Yeah. All right. Okay. That is for you to solve. Just solve that. Okay. Moving on to ecological succession. Now what happens is, when ecologies are being formed, when ecology is happening, ecological pyramids are coming forward, there is a concept called ecological succession. We're just discussing terms. We will use those terms later on. Okay. We're just discussing terms. So don't find any interconnectivity here. We are going one by one to the greater parts of it. So there is a term called ecological succession. We've seen ecology. We've seen ecological pyramids. We've seen how ecological structure works. Now we are talking about ecological succession. What is ecological succession? Just try to understand that ecological succession takes place in multiple stages. Why are there multiple stages in ecological succession? Because understand what ecological succession means. Okay. For that, let's understand what ecological succession means. Okay. What is ecological succession? Ecological succession is basically a very gradual process. Okay. A very gradual and predictable process. What is happening in this process? Okay. What is happening in this process? In this process, gradually we will see structure of biological community evolves. Okay. Gradually there is an evolution in the structure of ecology. Okay. In the structure of ecology or community, there is an evolution. Right? Yeah. what is happening is, just understand this. This is like, I'll give you an example. There is a relay race. Yes? Are you familiar with the concept of relay race? You must have done that in school, college, yes? What happens in relay race? We have 4 members across the ground. 4 members across the ground. One of them carries the baton, takes it to the second member, second carries to third, third carries to fourth, who finally reaches back to the finish line. Yes? If the first one covers faster, wouldn't the second one have to go, like, can go slower? Yes? They will be able to adapt. The first one has prepared something for the second one. Second one still goes fast and prepares for the third. Third one still goes fast and prepares for the fourth. And fourth one still runs fast so that can reach for the first time. Yeah? That is what is happening in the evolution, that previous generation that is living here. Yes, previous species that is living here, they will make it, evolve to make it more suitable for the coming generation. More suitable for coming generation. So gradually they are evolving. Gradually they are evolving. This is over thousands of years, okay? Hundreds and thousands of years. This is not easy. But this happens in successions. How? 2 primary types of successions, like primary succession and secondary succession that we see, that we will understand. Okay? It happens in 2 forms, that is primary succession and secondary succession. What is primary succession? Try to understand that. As the name suggests, this is the primary activity. Okay, as the name suggests, primary succession is what? It occurs in lifeless areas. Okay, essentially in lifeless areas. That is where primary succession will begin. No soil, or soil has been completely destroyed, right? Volcanic eruption has happened, whatever, glaciers are there. At that point, they will come up with pioneer species. At that point, they will come up with pioneer species. What are pioneer species? First organisms to arrive. Pioneers are first organisms to arrive. Okay. While new kind of species is taking birth, entire thing has been deserted. Now new life has to be born. Pioneer species will come forward. The first one to create life there. Pioneer species. Okay, pioneer species has come. They're the rock breakers. What do we call them? Rock breakers, because apparently there was nothing and they broke the rock and evolved from that. Rock breakers. So they will create the soil. They will change the soil, break down the minerals, add organic matter and give birth to life again. Give birth to life again. Right? So this is extremely slow. Hundreds to thousands of years it takes to actually do this. Yes, to actually frame this. This is our primary succession. How new life is born on areas that either never had life or had but got absolutely destroyed, and new life is being born there. Yes, you understand that? This is our primary succession. What is secondary succession? What is secondary succession then? In terms of secondary succession, we'll see that once life has been generated, it becomes easier. Yes, once it has been done, it occurs where community had previously existed but was removed by disturbance. Yeah? Yeah. What is happening here? Community had already existed but was uprooted. Now, since they were uprooted by flood or whatever, soil had remained intact. Now, you don't need pioneer species. Yeah, you don't need pioneer species to come and break the rock. That is not required anymore. That is not required because the soil is intact. You can just begin the life. You can just begin the construction. You can just begin the new era. Yes? Yeah. Here pioneer species will come, but they won't have to break the rock. Just remember that. Pioneer species are necessary because everything has been deserted. So here, pioneer species because soil is intact, would be simple as grass. Would be simple as grass. They won't have to break the rock. They won't have to prepare the soil. Grasses, weeds, they can grow, right? So naturally, since rock breaking is not required, since preparation of the soil is not required, this is much faster. This is much faster. Can you see that? This is much faster than primary succession, because foundation, that is the soil. What is the foundation of life? Soil, right? Sun, soil, plant, organisms. That's it. That is the cycle. So soil is prepared, so naturally this will take very less time, much less time. Yeah, so this is much faster as compared to primary succession. Clear? Is that clear? Do you understand primary and secondary succession? Okay. So based on that, we have 3 stages. Pioneer stage. What is the pioneer stage? What would be the pioneer stage? Just think about it. Pioneer stage is where hardy species like lichen, mosses, grasses stabilize. Then intermediate stage, small shrubs, pines, all these grow. Then climax, stable community, forest, vast forest, oak, hickory forest, anything that remains, until there is next big disturbance, it will continue to be stable. Yeah, that is our climax community. That is our climax community. Please remember that. Clear? What are the 3 stages? Pioneer, intermediate, climax. Pioneer, beginning with lichen, mosses, grasses. Second, intermediate, shrubs, pines, small. Third, climax, full-blown forest, full-grown forest that can only be destroyed once you are just eradicating everything on land. Only then they will be destroyed. Yeah? So there has to be some big thing to happen, big effect to come. Only then they would replenish. Yeah, clear? These are the stages of succession. This is ecological succession. Clear? Do we understand that? Ecology, ecological structures, ecological succession, ecological pyramids. We've studied all that. Do you understand these terms? Does that give you a clarity? Yes? We started with difference between ecology, environment and ecosystem. Food chain, food web, then we did ecological pyramids, transfer of energy, and then ecology, ecological structures, and succession. Is that clear? Yes? Absolutely clear. This has created a base. Now in this ecology, once pioneer species have come, climax communities have come, now everybody is going to interact with each other. In that interaction, we will see how this takes place, how the species come forward, how this happens. Yeah? Clear? So that is our next step, that is to understand what kind of species are there, why they are interacting the way, what is their characteristics. Some are keystone species, some are flagship species, right? So we have different kinds of species. So we'll talk about each of them one by one. Here, what kind of species are evolving here in all these stages, and how do we identify and use them? Okay, shall we go forward then? All right, so we have biogeochemical cycles. Next is biogeochemical cycles, through which everything is coming together, and we will go to our specific species. Yeah, what is biogeochemical cycle? Let's understand through this. Like there is a food chain that everybody is interacting with each other, environment is also interacting. And through that, life is becoming possible. Why? Because for that pioneer species to come up, for that pioneer species to grow, we would want to give it an environment, yes? Would we not? Would we want to give it an environment that, okay, you grow and then you turn into a climax community? To give that environment, this ecological balance is required. What is this ecological balance? Biogeochemical cycle. Yes, that cycle keeps everything running, because of which a favorable condition or environment is created for a pioneer species to take birth, or for a climax community to keep going. Both ways. Yeah. So let's understand what this biogeochemical cycle is. First of all, sun comes, Sun gives energy, plants grow, sheep feed, right? Now, nitrogen cycle is also going on because nitrification is happening. Okay, at the same time, phosphorus cycle is going on, phosphorus fixation is happening. Carbon cycle is going on because carbon dioxide is coming and going. At the same time, water cycle is going on because evaporation, transpiration, precipitation and rainfall, all that is happening. All at the same time, everywhere, everything is happening. One by one, let's see. Nitrogen cycle, you grow plants, they give nitrogen to the soil. Yes, they give nitrogen to the soil. Yes, or they take nitrogen from soil. When sheep eat it, they get the nitrogen. When they die, they're buried, they release nitrogen, nitrification. Simple. Yeah. Phosphorus cycle, how is it happening? Rocks are weathering, right? Weathering rocks give you phosphorus. Phosphorus combines through sedimentary rocks, once again becomes rock. Simple. Carbon cycle, carbon is released from organic matters, right? And once carbon is released, it takes part in photosynthesis. CO2 is formed. From respiration also CO2 is formed. But once it comes down, every CO2 is brought back. Same in water cycle. Water is there. Sunlight, heat is there. It absorbs the heat, evaporates, forms cloud, precipitation. Through precipitation, water back to the water sources. Right? This entire interaction, now this time the interaction is not between organisms, the interaction is between lithosphere, hydrosphere, atmosphere, cryosphere. All the elements of Earth, that is biosphere. When biosphere interacts with all its elements, yes, that becomes biogeochemical cycle. Organisms are also a part of it, but it is not led by organisms. Organisms are just a part of it. That is the difference. Organisms are a part of it, but the entire cycle is running in the environment irrespective of it, right? That is our biogeochemical cycle. Is that clear? Yes? Absolutely clear? Yes. That is our cycle, the biogeochemical cycle. Now, amidst this, species are interacting. Let's see what kind of species are there, what kind of interaction is happening. Shall we? Shall we do that? Okay. So species interact with each other. Why do they interact with each other? Either they want to support each other. Like, why do humans interact with each other? Why are we interacting? Right? Either to talk to someone, support someone, scold someone, or just convey information, or I'm conveying information, you are studying, that is also talking, a way of talking, digitally a way of talking. Yes, so we are doing that. Similarly, species or environment also interacts. Species also have a message. What kind of, either they are trying to support other species, either they are trying to support environment or species, yes, or they are a predator trying to find food. Okay, that's why they are interacting. Maybe they are mating, right? So, population. In all these manners, what happens is sometimes all of them benefit, right? Sometimes one benefits, the other loses. Yes, sometimes one is stronger, the other is weaker. Sometimes both of them are stronger, yet somebody has to lose, right? So multiple kind of connections are framed here between the species. Based on these connections, like what kind of connection do they have, whether they are going to benefit from this or not, whether they are going to take benefit of others or not, right? Amidst that, we have created segments. What kind of segments? The type of interactions that the species have. What type of interaction species have? Number one is mutualism. What is mutualism? We say mutual support, mutual decision. Where do we use the term mutual? When both are agreeing to it. Yes, both think that, okay, this is good for you, this is good for me as well, let's do it. That's it. That is mutual. So mutualism is similarly the same concept here. How both species are benefiting. They mutually agree because they are both benefiting. Like Bees and pollinating flowers. For flowers, it is necessary that bees take the pollen from one flower and give to the other flower, the male flower or the female flower. That's how the pollens are transferred. From the male flower to the female flower, pollens are to be transferred. They need bees for that. And bees need flowers to obviously rest and feed. Right? So both are benefiting. Yes, that becomes mutualism. What is commensalism? One benefits, other is unaffected. One is benefiting from it, but it is not a loss from the other one. How so? That is, barnacles attached to a whale. Barnacles attached to a whale. Barnacles are getting a ride, a free ride, but whale is unaffected because the skin is so thick. The skin is so thick that whale is unaffected, but barnacles get their feeding. Yeah, barnacles get their food. Clear? So whale is unaffected, but barnacles are getting what they want. Then there is parasitism. Parasitism, one benefits at the expense of the host, right? Whoever is the host, like here whale was the host and barnacles were just parasites, right? So in kind of parasitism, what we say, the host suffers while the parasite benefits. Okay, like a mosquito bites you. Mosquito drinks your blood and gets heavy and strong, right? But you get that pinch and itch. That is not good. So you are the host, you are getting troubled, but the mosquito is benefiting. Yes, that is parasitism. Similarly, ticks on a deer, same thing. Yeah. Then there is predation. One species that is predator eats another that is prey. Yeah. Predator to prey, that has been happening, hunting, simple hunting. One has to be a predator to hunt, right? Lion eating a fox, simple, predation. So one species will eat, other will be eaten. Competition, species are going for same limited resources, like humans are going for same limited resources. So naturally, nobody is going to benefit. We are all going to end up dead. Two tree species competing for sunlight. Okay, one is tall, one is short. Both of them are competing for sunlight. Like they also want it, they also want it. But sunlight will fall wherever it will fall. Money will come wherever it will come, regardless of how much we fight for it, right? So some people are like fighting day in and day out for the money, the property and whatnot, and ultimately anybody who could enjoy just dies. Yeah, they lose their children or they lose so much in the process that they're not able to enjoy what they fought for. Yeah, same thing is happening here. This is competition. Clear? These are the ways in which species interact and the effect it causes. You understand? These terms are directly asked. Terms are directly asked, very important for UPSC. They are directly asked like what is happening in this case. One is benefiting, or they will give you examples like find out which is parasitism, which of these relation indicates mutualism, like that. Such questions are formulated. Do you understand that? Yes? Yeah. Please remember, very important for UPSC. They keep asking this repeatedly. Either they give it in the statement formation or they give it in the match the column formation, but they definitely ask this. Yeah? Can we remember that? Yes, simple? All right. Moving on from species interaction, we see the other thing that is here is different kinds of species. Okay. We'll talk about different kinds of species. We have keynote species, we have flagship species, we have umbrella species. These three kind of species, very important. Number one is keystone species. Keystone species are basically, they have disproportionately large effect on natural environment. Yeah, that means they are like, binding element of the environment, you can say, the binding element of the environment, because if you pull them out, the entire environment starts breaking down. Yeah, environment starts breaking down. Any particular environment goes under breakdown if you pull this particular species. Yeah, they are supporting the entire food chain, they are supporting the climate, they are supporting the area, that they are signifying that this is the area, and if you take them out from there, rest of this abundance won't be able to survive. Ecosystem collapses or at least changes drastically. right? Yeah. So why do they're called, you see, there's an arc. When you form an arc, there is this one stone. There is this one stone that is holding everything together, right? One stone that is holding everything together. That is why they're called keystone species. The one species that is holding everything together. Okay. Yes. What are the examples? Sea otters, right? They eat sea urchins. Without otters, urchins will overpopulate. So they will destroy the kelp forest, which is obviously a home for hundreds of species, right? So that's why you need otters there. You need otters there so they keep the urchins in check. And if they are in check, the forests survive. Clear? This is our example. This is our keystone species. Did you understand that? In house also, in your home also, there must be this one member. When that one member leaves, the house suddenly feels very sad or, very silent. Like, okay, this person is the An Ban Shan of the house, right? You do feel that, right? They're the fun part. They're the fun part that they make every event so dramatic and everything. And once they leave, everything is like so dull. The keystone species, okay? The keystone species, all right? Okay, moving on to the flagship species. The next is flagship species. Flagship is like we have flagship schemes. It is similar. How it is similar? They are chosen to raise support for biodiversity, right? Because you see, they have some charismatic enigma to them. Because of their charisma or because of their, chosen capacity. If you want to raise support for a region, you bring these species and everybody is going to come and support you. Yes? Yeah. So animals that are cute, majestic or well known, so they play the mascot role. Okay, they are the mascot under the name of whom everybody is going to get support. Everybody will get the support because of this flagship species. Yeah, testing. Clear? Marketing, public relations, the face of the campaign. The face of the campaign. That is flagship species for you. Yeah? We can say the face of the campaign. No matter who the campaign is for, right? The face of the campaign is going to save everybody. That's it. Like the giant panda, WWF logo, or the Bengal tiger, right? Because everybody knows we want to preserve Bengal tiger, so they will put more money. Or the pandas that's so darn cute that everybody is going to want to preserve them, right? Yeah. So naturally, everybody is going to put your money there. Clear? These are flagship species. Is it clear? Keystone and flagship. Do you understand the differences? Yes? Yeah. Then we have umbrella species. Umbrella species are like, they have very wide geographic range, right? How so? If somebody has a wide geographic range, that means they can be sustainable anywhere. They can be put down anywhere. Along with this, they have particularly a very complex habitat requirements. Okay, they have very complex habitat requirements. Why complex habitat requirements? Because that is their requirement, simple. And because of this complex habitat requirement, it so turns out that they take so many services, so many aspects into their environment that most of the species, most of the different species can all be covered under this, Yes? We can cover all of them under this. That is how wide their requirement is. Clear? See, for one person, let's say there are 5 people at a restaurant and all of them have ordered food. Okay, one of them has ordered all the different Chinese, Italian, Indian, all kinds of food, like 5 varieties of food. Rest of the people, whoever wanted those cuisines, is now like, okay, everything is on the table. What do we order? We don't need to order. Everything is on the table. They've also ordered beverages. They've also ordered Chinese. They've also ordered Italian. They've also ordered Northeastern food. They've also ordered all kinds of food, right? South Indian, North Indian, all kinds of food. So now we don't need to order anything, right? That is what? That person is acting as an umbrella, taking care of everybody, right? That is their own requirement. So this species has such a wide requirement that their requirement suffices requirements of many different species. Now we don't need to create special environment for them. We just put them all together. And they're like, all of you are preserved now, right? We've created conditions for all of you, all together. Yes, that is umbrella species. For example, the northern spotted owl or grizzly bears. Okay. Vast amount of old growth forest they are protecting, because naturally it also protects insects, birds, plants. Everybody is protected in that same forest. Clear? Yeah. These are umbrella species. These are the three kinds of species we needed to know. Is that clear? Do you understand them? Yes? Yeah? There is another species that are generally not talked about, but they are indicator species. Okay. What are indicator species? They indicate something, whether water is bad or good. Okay. Because their presence, let's say there is Gangetic dolphin. Okay. Gangetic dolphin is an indicator species. Why? Gangetic dolphin can only survive in clean water. If they are dying, that means your water is not clean. So are they indicating that water cleanliness is going south? Yes? Yeah, that is indicator species for you. Very simple. Indicator means they indicate a particular kind of condition in the environment that they're living in, because they can particularly survive in a certain kind of condition, and if they are there, that means that condition is there. Clear? If Gangetic dolphins are there, that means the water is clean. Yeah? Okay. Let's see the difference. Keystone, Flagship and umbrella. I think everything is clear. Keystones are for ecological balance. Flagships are for public icon. Umbrella are for habitat protectors. Yes? All right. This is the talk about our species. I hope that is clear. Yes, I hope that is clear. We finished up the chapter regarding the species. First, we finished up the chapter about basics of ecology. Second, we finished up the chapters about basics of species and their interaction. Third, we are starting with ecological or biodiversity hotspots. Yeah. Next, we are starting with biodiversity. Biodiversity hotspot. What is an hotspot? These days, the only hotspot we know is the internet hotspot. Okay. Hotspots are like areas that are either, very well preserved or need preservation. Yeah, extremely need preservation. We create them hotspots for special attention, right? Anywhere there is a variety and that becomes a very dense zone of something, that becomes a hotspot. In terms of biodiversity hotspot, what does it mean? That we have areas specifically designed, biodiversity hotspot or biogeographic regions, that are significant, yes, because there is a large scale biodiversity, but are threatened for destruction as well, right? They are significant. Why? Because they have a lot of biodiversity. Simple. The areas that have a lot of biodiversity, but they are under threat also. Why? Because of destruction. Because of destruction. Clear? Yeah. However, there are still certain criteria to qualify as a hotspot. Okay. Who decides that? Conservation International. There is this body called Conservation International. They are the ones who decide who will qualify as a hotspot, who we will call as a hotspot, and they will tell us this is a hotspot and you need to preserve them, and then the preservation task is taken over by IUCN. Determination task is done by Conservation International and the preservation task is taken over by IUCN. So we'll also talk about IUCN. Conservation International is fine. We don't need to go that deep, but IUCN we need to understand very clearly because it has been repetitively asked. Okay. Yeah. So let's begin with biodiversity hotspots. You understand what they are? Yes? Yeah. So Conservation International has given us two conditions. This Conservation International has given us two conditions that need to be fulfilled. Okay. Two conditions to qualify for a hotspot. Why? To qualify for a hotspot. Okay. What are the two conditions? Just try to understand what are the two conditions. Number one is endemism. What is endemism? That particular area that you want to declare as a hotspot should have species. What kind of species and how many species? That is what endemism here is all about. That is, it should contain at least 1500 species of vascular plants. 1500 species of vascular plants. Number one, that is 1500 species of vascular plants. This is the first condition of endemism. Clear? Yeah. That should not be found anywhere else on earth. Not found anywhere else on earth. Okay, that is the main condition. Endemism, they should be endemic to this particular location, this particular hotspot. That is when we will declare it hotspot, right? And the second is threat level. What kind of threat it should be facing to become a hotspot so that it can be given protection. It should have lost at least 70% of main vegetation. Lost at least 70% of original main vegetation. Original main vegetation. That is when it will become a hotspot. 70% should have to be lost. 70% is lost, it is anyway critical, right? So this is the threat level that Conservation International has asked. Clear? What are the words biodiversity hotspots? These are the biodiversity hotspots. Okay. Here you'll see a province. Tropical Andes, Central Chile, Brazilian Cerrado. Okay. We have Brazilian Atlantic forest also, succulent Cardo and Cape Floristic. Then we have West African forest. In India, we see Western Ghats, right? That expand till Sri Lanka. Then Sundaland, South Central China, Southwest Australia also has some part of it. Mediterranean Basin also has some part of it, right? These are the areas, Eastern Arc and coastal forest of Tanzania and Kenya. These are also included. This is the biodiversity hotspot of the world. Yes? Clear? Now their conservation, this declaration is done by Conservation International, while the conservation is actually done by IUCN. Okay, the conservation of all the biodiversity hotspots that you've just seen is done by IUCN. Okay, what is IUCN? What is IUCN? We know that. Come on, we know that. IUCN, International Union for Conservation of Nature. What is it? International Union for Conservation of Nature. For Conservation of Nature. Exactly. That is IUCN for you. That is IUCN for you. Global authority listing the threatened species, red list, green list. That is what they call out, right? So this is an international organization working for conservation of nature. Established in 1948 in France. Where was it established? France. When? 1948. Previously, it was called International Union for Protection of Nature. Then, and World Conservation Union from 1990 to 2008. And since then, it has been called IUCN. Okay, these are the previous names it had. Both government and civil society organizations are included. Very important statement for prelims. Very important statement for prelims. It includes both government and civil society organizations. Headquarter, Gland, Switzerland. Gland, Switzerland. Clear? This is the basic of IUCN. What IUCN does is it releases red list. It also releases green list. There are multiple lists, but the most important one that is asked repeatedly is red list. So we'll talk about the red list and categorize the species. Okay. From all the species that are evaluated, we have the ones for whom we have adequate data and the ones for whom we don't have adequate data. Yes. First of all, they are evaluated and some are not evaluated. Second is we have adequate data, we don't have adequate data. We don't want to do anything about these. We will focus on adequate data. In adequate data, first of all, the first thing we have is least concerned. No concern. They're amply populated. They have good habitat. Everything is fine. Near threatened is the next stage, like, okay, somewhere near the threat. They don't have a threat yet. They are near the threat that, okay, somewhere down the line, if this continues, they will go to threat. This is very easy stage. Not much is done regarding the species of this stage. Then comes the threatened category. Okay, then comes the threatened category. We have three kinds of threatened categories, that is vulnerable, then endangered, and then critically endangered. Vulnerable means they're still vulnerable to the conditions. Endangered means, okay, now they have entered the danger zone. And critically endangered is now it is very difficult to save them, right? Because after this, they will be extinct in the wild and then completely extinct. Why too? Because they are extinct in the wild, but maybe somewhere their population still survives. But completely extinct means completely gone from the earth, wiped from the earth. Yes, cannot be seen anymore. These are the stages of the red list. Least concerned, near threatened, vulnerable, endangered, critically endangered, extinct in the wild, completely extinct, right? Increasing order of threat of extinction, increasing order of risk of extinction. Yes, least concerned, near threatened, vulnerable, endangered, critically endangered, extinct in the wild, and completely extinct. Clear? Yes. This is how they release the list for species every year and come up with new names there. Yeah, they come up with new names there, adding on to the list, adding on to the names of the species. They keep evaluating and then they keep adding the names. Is that clear? Yes? Yeah. So now, since the task of IUCN is conservation, yes, once they make this list, once they identify the status of the species, what they'll do is, what will they do? They will conserve them. How do they conserve them? The question is, how do they conserve them? For that conservation, they have two methods, in-situ and ex-situ. Clear? They have two methods, that is in-situ and ex-situ. Methods of conservation that are done by IUCN, right? Two methods, in-situ and ex-situ. Okay. What is this in-situ and ex-situ? In-situ is on-site conservation. In-situ is on-site conservation. Okay. Ex-situ is off-site conservation. What is happening is, sometimes wherever the species is, right, the species that needs conservation, where it is, there itself we will provide it extra protection, we will provide it good habitat, food, health, etc., etc. Yeah. But at the same time, off-site conservation, that means wherever the species is staying, that environment, climate, food chain, for any reason we see that this is not a favorable position, favorable location to be in. So they need to be shipped off to some other location and some other kind of environment for their sustainability, for their survival. That becomes ex-situ, off-site conservation. They are taken out of that environment, put into some other favorable condition, and there they are conserved, outside their natural habitat. Yes? Sounds weird, right? Because natural habitat is what an animal would need to survive. But sometimes that natural habitat is not giving them anything and everything they need. So we have to pull them out of that, create a new favorable environment for them, put them there and allow them to flourish. Right? That is off-site. That is off-site conservation. And on-site conservation is very similar. Within their natural habitat, we will conserve them within the natural habitat. Is that clear? Yes? Simple to understand? Good enough? All right. These are the methods of conservation. To understand the difference between in situ and ex situ more clearly, we have this chart where we see in situ means on site, ex situ means off site. We've already discussed that. Method within the natural habitat, outside the natural habitat. We've also discussed that. Environment, in situ is national park, wildlife sanctuary, biosphere reserve that is already created for them. Ex situ is like you push them out to zoo, aquarium, botanical garden, anywhere. You take them somewhere else where you create an environment for them. Yeah. Pros of in situ: maintaining natural evolution, ecosystem interaction. It is cheaper. You won't have to create new environment. Ex situ, total protection is given here from predators, poachers. So this will give them intense care that they need at that time. Yeah, sometimes you cannot treat everything at home. You have to take people to hospital, right? Now, if, the old age people, generally when we are taking them to hospital, they're like, oh no, I don't want to die in hospital. I will stay at home. You won't die. If you go to the hospital, you'll get a treatment and you won't die. You will have to live, right? So that happens. But sometimes it is absolutely necessary to take them to the hospital because they need extra care that family members cannot provide. Right? Exactly, the same condition. But there are cons also. What? In situ conservation, very hard to control because when you leave them in the environment, there is a chance they're going to get hunted, they're going to get eaten, they're going to get attacked, they're going to get diseases, they're going to get into interactions with other species. You cannot control that. But in ex situ, their interaction gets lost. They're not in interaction. So maybe like it is very expensive, they lose their natural behavior because if you keep them outside, they won't get into the habit of hunting because you're feeding them. You're giving them food on the platter and telling them you don't have to hunt, we will give you the food. We want you to preserve your energy. That way they'll forget to hunt, right? Their innate hunting capacity gets lost. That changes them, right? They lose their natural behavior. Clear? This is in situ and ex situ conservation. Please tell me you understand that. Yes, is that clear? Absolutely clear? Any doubt, any query? Anything? No? Okay. So I think the species part is clear here. Yes. So we have mentioned these areas, national park, wildlife sanctuary, biosphere reserve here, right? So when species are taken care of, it brings us to their surrounding. Species we have taken care of. Now we need to take care of their surrounding. The surrounding entails protected areas. What does surrounding entail? Protected areas. So we have to understand what protected areas are, how do they work, what kind of structures do they have, and how they're working. Okay. Let's solve a question first. Regarding IUCN and CITES. Yeah. Read the question. With reference to the International Union for Conservation of Nature and Natural Resources and the Convention on International Trade in Endangered Species of Wild Fauna and Flora, which of the following statements are correct? This has been asked in 2015. Read the statements. IUCN is an organ of UN and CITES is an international agreement between governments. IUCN runs thousands of field projects around the world to better manage natural environments. CITES is legally binding on the states that have joined it, but this convention does not take the place of national laws. Okay, this is the question for you. CITES, you know about CITES, right? Yeah. Okay, this is the question for you. Try to solve it, okay? We are moving towards our next topic, that is protected areas. Protected areas. Okay? Yeah. What are protected areas? Let's talk about that. What are protected areas? Let's talk about that. let's say you're playing a game. Okay, you're playing a game, let's say hide and seek. When you're playing hide and seek, you see the members, you decide who's going to hide, who's going to find, and all that is done. Then you say like, okay, from Arjun's house to Priyanka's house, that is the area. Do you do that? Right. We set an area in which people can hide, because otherwise city is huge. Anybody can hide anywhere, and that would just not give us the benefit of it, right? We won't be able to play the game. So we decide that, okay, this is the limit. These are the houses, these are the number of houses which you can enter. This is the place that you can enter to hide. Once you've hid, the game starts. Similarly, animals also have their territorial sense. They have their territorial sense and they tend to restrict to that territory. When they are restricting themselves to that territory, and if we want to protect either the environment or the organism, what we do is we declare that entire territory as a protected zone. Okay, like from here to here, this is protected by us. You are not supposed to do anything here without our permission. That is area identification. Nothing but area identification. You are protecting areas under different segments, right? If you want to protect wildlife, you will declare wildlife protection area. If you want to protect the vegetation, the forest area, you'll declare it as a national park, right? So under different criteria, you declare a protection scale for them so that nobody else can do anything there without your permission. Like identifying an area of your house. You buy the land, you create a boundary there, okay, nobody can encroach our land, right? Nobody can do anything there without our permission. Clear? Same way we have protected areas. Now these protected areas are either to protect the environment or to protect the species or to altogether just take care of an area. Yeah? Take care of the biodiversity there. The entire biodiversity there. Whatever kind it is, the entire biodiversity there. So we declare some areas as protective areas. They are managed through legal means. They are managed through legal means, right? They are specially denoted, specially marked, so that the limitations are set clearly. And then there are restrictions imposed, like you cannot go here, you cannot set up shop here, human entry is not allowed, etc., restrictions, right? So they become different kinds of protected areas. Okay. So now basically what we have is, in different terms of protection areas, we have national parks, we have wildlife sanctuaries, we have biosphere reserve. Okay, one by one we'll talk about them. Most of them in India, they are primarily categorized under Wildlife Protection Act 1972. They come under Wildlife Protection Act 1972. So we are going to preserve the area here, we're going to support the area here, we're going to protect the species here under national park, under wildlife sanctuary, under biosphere reserve. That is what we are going to do. But how? National parks are basically highly restricted, no human activity zone. Okay. What are they? Highly restricted, no human activity zone. Okay. So if there is no human activity, naturally we don't need any demarcations of the area. The entire area itself is a no human activity zone. If humans are allowed, then we have to create restrictions. But if humans are not allowed at all, why do we need restrictions? So we don't create that. Grazing, private land holding, nothing is allowed. No human activity, no grazing, no land holding. Nothing, humans are not allowed. That's it. There is a board, restricted area, you don't enter. Simple as that. You just don't enter. Second is wildlife sanctuaries. In wildlife sanctuaries, there are certain rights given to humans. certain rights for humans. This is still protected, but with certain rights. Certain rights like grazing or wood collection. Like grazing or wood collection. Right? This is the basic difference that is created through this. Yes? But not for everybody. But not for everybody. For local communities. For local communities, because apparently since these are forests, tribals would be living here, you have to give them some right. Where would they go? Right? So for local communities, these rights are given, very specific rights, not diverse, and that too as long as they don't harm the wildlife. This should not cause any harm to the wildlife. Only then, if you cause any harm, all rights would be evoked. Clear? This is wildlife sanctuaries. Then comes biosphere reserves. Clear? Biosphere reserves are very large areas, so large that it can constitute one or more national parks. Yeah, it can constitute one or more national park or wildlife sanctuaries within it. Right? Within it, it can include national park, wildlife sanctuaries, everything. Right? So they are on MAB. That is man and biosphere. They're protecting both. Right? They're working on both, that is man and biosphere relationship. Okay. So naturally man is allowed here. Naturally man will be allowed here. Right? So they are creating a balancing conservation with sustainable development. What they're trying to do is balancing conservation with sustainable development. With sustainable development. Is that clear? Balancing conservation with sustainable development. This is biosphere reserve. Clear? Clear? Yeah. Biosphere reserves can be so large that we have this do you know box here. Okay. Just look at this. In 2021, what happened? UNESCO declared Muradhrava Danube, MDD, Muradhrava Danube, world's first 5-country biosphere reserve. This biosphere reserve is so large, consists so much that it expands around 5 countries. Not just national park or reserve. It expands around 5 countries over 700 kilometers. Muradhrava, Danube rivers. These are the rivers, Muradhrava and Danube rivers. Across the rivers, they stretch towards Austria, Slovenia, Croatia, Hungary and Serbia. Which are the 5 countries? Please remember this for prelims. Austria, Slovenia, Croatia, Hungary and Serbia. This is popularly known as Amazon of Europe. What do we call it? Amazon of Europe, spreading across 5 countries. How many countries? 5 countries. Please remember that. Austria, Slovenia, then we have Croatia, Hungary and Serbia. Clear? 3 rivers are involved. 3 rivers are involved across 700 kilometer stretch. That is Muradhrava and Danube. Muradhrava and Danube. Clear? Please remember this. So this is the difference between national park, wildlife sanctuary, biosphere reserve, the protected area concept in. Clear? Yes. Now, along with these levels of protection, we also have ecologically sensitive zones. Yeah, they don't fall under these categories, but they're still sensitive. They still need protection, and if not entire protection, they at least need some restriction on interaction. For that, we declare them as ecologically sensitive zones. What do we call them? Ecologically sensitive zones. Okay. So coming on to the next concept, that is ecologically sensitive zones. We'll come there. Okay. Before we understand this, just look at this diagram. That will help you understand how we divide the areas, how human and nature are altogether preserved. How do biosphere reserves work and how they are altogether reserved? Okay. The entire area, you see this blue bubble, that is the entire area. Transition area, this is the transition area. Transition, buffer, core. Transition area, you have human settlement also, research is also going on here, tourism is also going on here. That's fine, very easy going. Come to buffer, we only have tourism and education and training, no human settlements. Okay, little bit of human settlements may be as necessary, and then we go to core. Where only monitoring and research happens. That is our core. Okay, no human settlement, nothing, only monitoring, only research. The settlement part is only for the people, residing there to protect the area. So for them we need to create something, only for them it is there for research, but other than that nothing else is here. Yeah, nothing else is done. No tourism is allowed here, no recreation is allowed here, only monitoring and research, no education, training, nothing. Okay, this is how they are managed: transition, buffer and core. Clear? Yeah. Wildlife sanctuaries and biosphere reserves where man is allowed, this is what happens. Clear? Okay, moving on to eco-sensitive zones. What are eco-sensitive zones? Let's find out what are eco-sensitive zones. Eco-sensitive zones, we call them shock absorbers. What do we call them? Shock absorbers. Why do we call them shock absorbers? Because for protected areas, they are the ones who will first of all take the fall. Transition zones around national parks, sanctuaries, they are the transition zone, right? Let's say this is the national park. So any area around this has to be sensitive, right? Because from here, from this very boundary, a highly protected area is beginning. So you cannot just have a land mine here. Can you now? Now you cannot just start mining here right outside the border of it. You have to create some distance, right? You have to create some distance. For that, eco-sensitive zones are created. Yeah. Why? Creating buffer, minimizing the impact. Yeah. This acts as a buffer between the human settlement, dense human settlements, and along with that, the protected area. Clear? Yeah. Activities, some are prohibited, some are permitted. So in this ESZ, we have two kinds of activities. In this, we have two kinds of activities. What are the two kinds of activities? The basic purpose here is that we create a buffer. Okay. What are we trying to create? Buffer between human settlements and protected areas. Yeah. Now this is regulated. How is it regulated? They are classified into prohibited and permitted. Activities are classified into prohibited and permitted. Some things are prohibited and some things are permitted. What is prohibited? Major mining industries. Okay. Major mining activities, industries activities, all these are prohibited. Now there comes another category here. Some are regulated also. They're allowed but regulated. How so? What are the regulated activities? Like felling of trees? They're allowed but regulated, right? Somebody will keep a check on that. Permitted, everything permitted. Example, ongoing agricultural activity by locals. That is completely permitted. They can do as they want. Yeah. This is In the ESZ, ecologically sensitive zones, eco-sensitive zones, not the protected area. Just imagine, they also need such protection. They also need such regulations. Clear? That's how we preserve our areas. That's how we preserve it. Is that clear? That is eco-sensitive zone for you. Yeah. Next we have the kidneys of Earth. The kidneys of Earth. What are the kidneys of Earth? Wetlands and mangroves. The wetlands and mangroves. They are also kind of protected because they are important. They're important because they are, the holders of different kinds of species that are not found anywhere else. So they're very protected. Okay. Why are they protected? Because of the species, but also because they're the kidneys of the earth. Okay. They're refiltering the water, giving ground, helping in the replenishment of groundwater as well. So they are kidneys. Yes, they are in fact kidneys. How do they function? That is to understand what are wetlands and mangroves, because they are ecotones. Okay. What do we call them? Ecotones. Okay. Why do we call them ecotones? For that, we have to understand what ecotones are. Okay. What are ecotones? Ecotone is like a buffer zone. Once again, we'll come to buffer. Buffer is like, say, here we have land, here we have water. Here you will have a mushy thing. Okay, a combination of land and water, yes. It is not entirely land, it is not entirely water as well. This is a combination. So where two kinds of ecosystem, land is an ecosystem, water is an ecosystem, yes. Two kinds of ecosystem merge to form a third kind of ecosystem. Third kind of, why do we call it third kind? Because it is neither land nor water. And more importantly, it contains species also. It contains species also that are neither found on land nor found on water. Because this is a whole new kind of environment, so whole new set of species are found here. So it becomes its own ecosystem. It becomes its own kind of ecosystem. This is wetland, right? This is wetland for you, or any kind of system. This is wetland because we took land and water. If we take other examples, it will become another example. But this is ecotone. In general, we call this segregated structures coming together to form a combined entity, overlapping features and framing something new. That is ecotone for us. It has new species, it has new environment, and that needs protection because it is one of its kind. Yeah, it is framing naturally, so it is one of its kind. The amount of land, the amount of water create a new kind of chemistry where new kind of species are found. We cannot do that manually. You cannot force the land to mix up like, okay, go in the water. You cannot do that, right? So if we cannot create new, that means they are rare, and if they are rare, they need protection. Clear? Yeah? Okay. So wetland and mangroves, they are parts of ecotone, and ecotone are rare, so we need to protect them. Yes, do we need that? Exactly. So what are wetlands? Large areas saturated with water, permanently or seasonally, any which way. Mangroves, specific type of wetland consisting of salt tolerant trees. They're salt tolerant, as salty as the water gets, you put there and they will grow. This is an ecotone species. Mangroves are ecotone species. Wetland is an ecotone. Mangroves are ecotone species. Yes, they're called the kidneys of earth. Clear? Yeah. Location, wetlands can frame anywhere. Mix land and water, you have a wetland. Simple. Mangroves you find only in the tropical and subtropical areas. Yeah. Root, standard root system in the wetlands, and the mangroves we have unique pneumatophores. Pneumatophores are aerial roots. They are bouncing in the air. Yes? Yeah. How do they happen? Because the water is so dense, so salty, what they do is they dive in, then they come out like this. They come out like this to breathe. The roots are extended outside in the air. They're jumping in the air because they want access to the air, pure air, to get some oxygen. Yes? To get some breathing power, because down in the water there is no breathing capacity. It is so salty. Okay, so dense and so salty, they don't have any breathing capacity there. So their roots are dancing outside. There are pneumatophores. Yes, roots in the air, pneumatophores. What are they? Pneumatophores, aerial roots. Please remember that. Aerial roots, pneumatophores. Clear? Yeah, that is wetland and mangroves for you. Clear? All right. This is about our vegetation, protecting the areas, protecting the different kinds of areas under national park, wildlife sanctuary, biosphere reserve, eco-sensitive zones. And then there is this special protection given to wetlands and mangroves, being called the kidneys of earth, because they get water and put it down in the underground, right? So that replenishes our groundwater. That's why kidneys, purifying the water and giving pure water to the ground. Yes, that is our kidney. Clear? Yeah. This was the vegetation. This is the protected area, how they are protected. And now, since we have given protection to species, we have given protection to areas. Now, what we need to understand is how they are interacting with the environment. How is environment working? Okay, we've talked about the land and species and protection, everything. Let's jump up to the environment now. For Earth, equally it is important. Let's see what environment is doing, how carbon is reacting with it, carbon dioxide is changing it, what is happening. Okay, so we are going to the environment stage of ecology. All right, so that is what we will begin now. We will talk about the carbon capacities and how carbon sequestrations happen, what is blue carbon, all these things we will talk about now. Is that clear? Shall we do that? Yes? Okay. So carbon interactions are nothing new. It has been happening always and naturally. It is kind of naturally occurring segment. Yes? Yeah. So since it is naturally occurring segment, naturally there is carbon in the environment. There is carbon in the structure. So why is it so important for us to, manage this? Why is it so difficult for us to actually manage this? More than important, it is very difficult for us to manage this. See, blue carbon we are studying with wetlands because wetlands play a huge role in carbon sequestration. Blue carbon is kind of like carbon stored from the environment into the water sources. Into water sources. How is that happening? How is that happening? Now we are doing this with wetlands because wetlands play an important role there. Wetlands will play an important role there. So we'll do with wetlands. Okay. But other than that, we need to understand what blue carbon is because it gets captured and stored in the coastal and marine ecosystems. Yes. What happens is we have terrestrial forests. Okay. These terrestrial forests, they are going to capture carbon. Yes. They get most of the green carbon. Okay. What they are getting is green carbon, we will get blue carbon now. Coastal ecosystems like mangroves, seagrasses, let's say they are mangroves now. Okay, let's say they are mangroves now. So if they are mangroves, what will they do? These mangroves, seagrasses, salt marshes, they are very much efficient in sequestration carbon. Okay, they are much more efficient in pulling out the carbon from environment. Okay, carbon sequestration process is much better here. So they will pull out the carbon in a very efficient manner. Yes, we can say that they are sequestrating carbon. Power sediment, if we say that land forests they store most of the carbon in biomass, the trees. Blue carbon ecosystem stores 90% of that in the soil or sediment below them. Okay. Where will they store this? In the soil or the sediment below them. Okay. So they are much better at this. They will sequestrate and push it down. Get more, push it down. Normal trees, what they do is they get and store it in themselves. They store it in themselves and that's why they have a limited capacity. right? They have a limited capacity, and when these ecosystems are destroyed, if you destroy mangroves, they will ultimately release CO2. They will ultimately release CO2. Yes? Release centuries of stored carbons into the atmosphere, and that's why they become carbon bombs. They will release everything out if you cut them down. Yes? So they become carbon bombs because they have so much stored. They have so much stored, right? Yeah, that is blue carbon for you. Yes, that is blue carbon for you. Captured and stored in the coastal or marine ecosystem. That is coastal and marine ecosystem. Yeah. So naturally, they will be stored. Clear? That is our concept of blue carbon. That is our concept of blue carbon. Next thing that we are going to talk about is the environmental acts. Okay. We'll start with environmental acts to understand what kind of acts are there in India to actually preserve environment. What are we doing to preserve the environment, animals, habitat, protected areas, everything. Everything. Like we just discussed Wildlife Protection Act 1972. That is one of them. We'll talk about that. All these acts and policies and things that we have, they are generally constituting into a segment where we have developed a system in India that we want to protect the environment, and we have set a procedure how to protect the environment, right? So all these acts work towards that. Very simple. Yes, all the acts would work towards that particular thing. Clear? Yeah. So that is what we will study in terms of environmental acts to understand how these acts are working and how they will be able to protect us. Yeah? Is that clear? Okay. So that is what we are doing, and we'll study about the environmental acts, okay? So the first act we have is Wildlife Protection Act 1972. 1972, that is for the protection of wild animals, birds and plants. The main thing, they include 6 schedules. They include 6 schedules in the act that are necessary, that step by step protect the species. Like now they have been streamlined to 4 itself, which provide legal basis to national parks, sanctuaries. And the most important thing this act does is it creates National Board for Wildlife. Okay, this board is consistently working towards making sure that the act is implemented, the act is followed, the act is processed. Yeah, so that is the most significant advantage of this. Second, we have Environmental Protection Act 1986, Umbrella Act. Entire environmental coordination is under this. Entire environmental coordination, right? This was enacted after Bhopal gas tragedy. Right, empower central government so that they will set some standards regarding water, gas, etc. usage, so that qualities are maintained such that it doesn't harm the environment. Yeah, to maintain that quality standard. Clear? Then we have Forest Conservation Act of 1980, that is checking the deforestation and conserving the forest land. How is it doing so? It is mandating that state government should obtain prior approval. From whom? From the central government. State will take prior approval from the central government. For what? They will take specifically before diverting the forest land into anything. Now, state cannot directly go and like cut down the forest, create development, create infrastructure. No. They will have to take permission from the central government, only then they will be able to divert the forest land. Yeah. This has been created under Forest Conservation Act 1980. Clear? Yes? Okay. Next we have is Biodiversity Act. The primary objective is to conserve biological diversity, of course, as the name suggests. But the most important thing it does is it creates 3-tier structure. What is the 3-tier structure here? Number 1 is NBA. NBA is basically National Biodiversity Authority. Then we have State Biodiversity Authority, and then local or, basic level biodiversity management committees. All right, this is done through the act. Next we have Forest Rights Act 2006. This was done to recognize the rights of forest dwelling communities. Why? Because they kept saying that for forest protection, you've put on so many restrictions, but our entire life depends on this, right? We are living here. Our entire life depends on this. If we put on so many restrictions, what are we supposed to do? You should come up with something that safeguards our rights also. We also have certain rights. So that's why in 2006 Act, what was done? We safeguarded the rights of forest dwelling communities, legally recognized that forest and the forest dwellers have a symbiotic relationship. We cannot pull them out and expect the forest to be maintained as it is. It is their livelihood, it is their existence, it is their structure that is keeping the forest together, and it is necessary each way. Yeah, they are necessary for the forest is necessary for them. So we have to acknowledge that and we have to give them certain rights. Clear? This was identified in Forest Rights Act 2006. Forest Conservation Act 2023 amendment came, and because of this amendment, this exempts land within 100 kilometers of international borders for strategic projects. Yeah, international borders, 100 kilometers of international borders that are kept out of strategic projects. They're permitting activities like zoo, safari, ecotourism. This is allowed, but nothing other than that. Yes, this is allowed, but nothing other than that can be allowed here. Is that clear? Yes? All right. These are the acts that are there for protecting the environment, because this legislation has helped us, right? This legislation has helped us a lot to take control of the entire system, because if we don't have legislations, enforcing such laws would be very difficult, right? Enforcement and implementation would be very difficult of the rules and regulations that we wanted here. That's why we had to come up with certain acts, which we have improved from time to time regarding whatever problem we faced, whatever kind of demands that were risen. For example, forest dwelling communities, we had to make that change, right? So we did that from time to time to make sure everything is taken care of. Yeah, we did that. So everything is taken care of. Is that clear? Yes? All right. Now, one more thing that we need to do is solve a question based on this. Then we'll see our next structure. Yeah. With reference to Indian laws about wildlife protection, consider the following statements. Number one, wild animals are the sole property of the government. Second, when a wild animal is declared protected, such animal is entitled to equal protection whether it is found in protected areas or outside. Third, apprehension of a protected wild animal becoming a danger to human life is sufficient ground for its capture and killing. Yeah, take a guess. Try to find the answer. All right, all right. Very nice. This is your question. Just find the answer for this. I am not telling you the answer for this. Okay. Yeah. So this is our environmental acts. Now through these acts, we have come up with multiple institutions as well. Multiple institutions have been formulated through these acts. Okay. So what are we trying to do? What are we trying to do through these institutions? We are trying to strengthen our structure and decentralize the power so that everywhere there is specific structure to take care of the environment. Yes. So we have multiple institutions going around. We'll talk about them one by one. Okay. Multiple institutions are there. Clear? Yeah. We have our ministry first of all. What are the institutions? We have our ministry first of all, the central ministry, which is the apex body, for planning, promoting, coordinating all kinds of programs in India. Yeah. CPCB, Central Pollution Control Board. Yes, Pollution Control Board, which is a statutory body. Now this is asked, right? This has been asked repetitively. What is its status? It is a statutory body, the technical wing. What do we call it? The technical wing, which is responsible for data analysis, restructuring, to let us know which way to go. Yes, this is the technical assist. And with that, we have state level pollution control boards also, which are established under Water Act. Remember that. They are established under Water Act, but empowered by Air Act. Please remember that. Please remember that. Very important. Sorry. Repeatedly asked. They are established under Water Act but empowered by Air Act. Empowered by Air Act 1981. Please, please, please remember that. Okay. Yeah. Then we have NGT, National Green Tribunal. The NGT that is working on environment, as we know. Yes. NGT is working on that. They're specialized tribunals. They're judicial bodies. What kind of bodies are these? They are judicial bodies. Okay. Yeah. They are dedicated to fast tracking environmental cases, because any case that comes to them, NGT has this guideline that you solve it within 6 months. 6 months is the maximum deadline to solve any case that comes to NGT. Yeah. And how do they do that? For that 6-month guideline, they have both judicial and expert members working on a particular case. Both judicial and expert members, please remember that. Both judicial and expert members, 6 months of deadline. And lastly, they have the polluter pays principle. What is the polluter pays principle? What is the polluter pays principle? That whenever there is a pollution, whenever there is such a structure, NGT comes up with the pollution principle that says polluter pays principle and sustainable development. That whoever is polluting should pay. Whoever is polluting should pay. None of the other parties should pay. None of the other party has to pay. Whoever is polluting should be responsible for the payment of that environmental degradation. They cannot ask everybody else to pay. Yeah, it is not a combined thing. It is whoever is causing the pollution should pay for it. Simple. Yeah, that is the NGT's polluters pay principle. NBA, we have statutory body, oversight body. Yeah, NBA is National Biodiversity Authority. Okay, what is NBA? National Biodiversity Authority. Now this is also statutory body, oversight body regulating, biological resources, access and benefit sharing, like who should get access to what kind of resources, how we are to leave some resources for forest dwelling communities, how we are to get access to that, how we are to utilize it, how much we will get, the sharing, everything is decided by National Biodiversity Authority. Yeah. They also have 3 stages, national, state and local. Clear? National, state and local 3-tier system. This is to implement the Act of Biodiversity. These are the major environmental institutions working in India at the moment. Apart from, the ones established by agreements, Paris Climate Agreement, Kyoto, etc. We'll do that. This is just the governmental part, like our based on the legislations that we have. Based on those, the governmental part, what kind of bodies do we have? These are the bodies. We have the ministry, we have the NGT, we have the advisory bodies, the CPB, yes, all these bodies. Clear? Exactly. So these are the environmental institutions that we have. Next is international conventions. Next thing we have to cover is international conventions. What kind of conventions are here? What kind of conventions are run in India? And along with that, how these conventions have affected, because mostly international conventions are obviously global. Most of them are what India has signed into, and how that has impacted India's environmental strategies that we have to see. Yeah. What is happening is international conventions, as they might have been created, but at the time of creation or at the time of signatory, as we discussed, that this is basically for dealing with cross-border issues, cross-border environmental issues. So if there is any species that is getting extinct from across the world, right, like for example, recently India has come up with the Big Cat Summit. Yeah, we've come up with the Big Cat Summit, where we are inviting all the nations that have big cat, that is leopard and etc. Multiple species are included here from the cat family. Yeah, from the cat family, multiple species are included here, which are getting extinct and which are generally threatened everywhere. right? India is doing everything to support the tiger population, right? We have Project Tiger. So to save that, India has come up with the Big Cat Summit. And in that, we've asked multiple nations to take part, like China is refusing to take part in this right now. Yes. And as a fact, we know that China has very less population of cat family, and they really need to preserve that and try to increase their habitations. But they're not doing that, and they're again refusing to become a part of the Big Cat family. Yes, the Big Cat Summit. So naturally, we are taking steps for that, international steps for that. And this is cross-border issue, environmental issue that countries take lead at. India is taking lead at the Big Cat Summit. Other countries have similarly taken lead at different species. And so international conventions are running. Yes? Yeah. So we have, conventions for different issues, like for climate change, we have separate, for wildlife protection, we have separate, for particular bird species, we have separate, right? Similarly, like that, we have multiple bodies. Yes, like UNFCCC, IPCC, these are working for climate change, right? So for climate change framework, we have separate bodies. For other frameworks, we have other bodies. So one by one, we'll see all kind of bodies. Yes, all kind of conventions that are signed by India, all kind of structures that are working for that. Clear? Yeah. All right. So we'll come to that. Number one, we have for climate change framework. Number one, we have for the climate change framework. Okay. For the climate change framework, what kind of bodies are working? We have two bodies, that is UNFCCC. Yes, do we know that UNFCCC and IPCC? UNFCCC and IPCC. UNFCCC found in 1992. Right, IPCC, Indian version of it, scientific backbone. Yes, yeah. This was found under Kyoto Protocol and Paris Agreement. Clear? Yeah. This follows the Kyoto Protocol and Paris Agreement. Yeah, it follows the Kyoto Protocol and Paris Agreement. Clear? Yeah. For species and habitat protection, similarly, for species and habitat protection, we have other two bodies. That is three conventions actually. Ramsar, CITES and CMS. Ramsar, CITES and CMS. Yeah. Ramsar Convention for wetlands. CITES is for illegal trade. Washington Convention. Illegal trade of species. This is done through Washington Consensus. Okay. This is Ramsar Convention, CITES, Washington Consensus or Washington Convention, you can say, right? And then CMS, migratory animals. CMS is specifically for migratory animals, to protect them, to give them good habitat, to give them proper environment. This is done under Bonn Convention. What is the convention? Bonn Convention. You understand the purpose? Yes? Yeah? Exactly. Clear? Okay. Then thirdly, we have the Biodiversity Trilogy. The Biodiversity Trilogy. What kind of trilogy do we have? We have the trilogy where number one, we have CBD, Convention on Biological Diversity. Second one, we have Cartagena Protocol. And the third one, we have Nagoya Protocol. Okay. CBD, what is it? Very simple. CBD 1992 main treaty. The main treaty we have regarding biodiversity, it has 3 goals. Okay. It has 3 goals. What are the 3 goals? Majorly conserving diversity, using it sustainably, sharing the benefits fairly. Conserving, using fairly, using sustainably, distributing fairly. Okay. These are the 3 goals: conserving the biodiversity, using it sustainably, and then distributing it fairly. These are the 3 goals of CBD. Okay, CBD, Convention on Biodiversity, Convention on Biological Diversity. Clear? Then we have Cartagena Protocol. Cartagena Protocol is of the year 2000. Cartagena basically deals with movement, right? Regulates the movement of LMOs, living modified organisms. Movement of LMOs. What is LMOs? Living modified organisms. That is like genetic diversity. Yeah, genetic diversity. This is what Cartagena works on. What does it work on? LMOs. Okay, modern biotechnologies, GMOs from one country to another. Why? Because diversity might hamper human health, right? So the movement of GMOs is restricted by Cartagena. Then we have Nagoya Protocol of the year 2010. You must have heard the name of Nagoya Protocol. Nagoya, access and benefit sharing. What does it do? Access and benefit sharing. Okay. Access to what and benefit sharing of what? That when a company or country uses genetic resources, like let's say there's a medicinal plant, right? If they're using from another country, the benefit is shared with the provider also, right? Provider or the community or indigenous community, anybody who's sharing with you that knowledge, you should share the benefit of that product with that also, right? So that is access and benefit sharing. Countries or bodies using knowledge to frame a product, or the product itself, using knowledge or the product, should share the benefit with the provider, whoever it is. Whether it is a community, whether it is a forest, whether it is, particular entity, yeah, whoever is doing it, a particular community is doing it, or whether a country is doing it, you share the benefit. That is Nagoya Protocol for you. Clear? Do you understand that? Exactly. So to sum up, we have UNFCCC 1992, reducing GHGs, Ramsar Convention for Wetlands 1971, CITES 1973, stopping illegal wild trade, CMS 79, international boundaries, Cartagena 2000, genetically modified organisms, Nagoya, access and benefit sharing. Clear? Yeah. These are the international conventions that are working, and they're working for species and habitat. There is Ramsar, CITES and CMS that we have already done. Okay. These are the international conventions that we needed to know about. The very basics, like what they are, what do they constitute, what do they follow, that is what we needed to know. Yeah, the very basics of it. Clear? Because questions from environment are not very deep. They're just confusing because a lot of terms, a lot of terminology, a lot of technicality, a lot of facts are there, right? That's why we just need to have basics cleared off so that we're not easily confused. We can easily guess the statements. Clear? Yeah. All right. Moving on to our next topic, that is greenhouse gases and related conventions. What are greenhouse gases and what are its related conventions? Okay. That is what we are going to do to understand greenhouse gases, to understand the emission, to understand why it has become such a huge problem for us, and why their emission is, the entire world is talking about it. And we try to figure out what greenhouse gases are, and then we try to see the related conventions, right? So greenhouse gases, basically, see what happens is there are some gases that trap heat in the atmosphere. What do? They trap heat in the atmosphere. Like when they are released, they somehow heat up the environment. And create a greenhouse effect. And that effect leads to climate change. That effect leads to the destruction of ozone layer. That leads to the disturbance in the heat budget of the earth, right? So these gases and their emissions we need to control. To control that and to make sure that they are kept in check, what we are doing is we have certain conventions. To control these greenhouse gases and all these effects that it comes with. Yeah, exactly. So the greenhouse gases, like there are primary greenhouse gases, and then there are global warming potential greenhouse gases also. So the first one that we see is the primary greenhouse gases. Greenhouse gases. Primary greenhouse gases like CO2, methane, right? Nitrous oxide, that is N2O, and we have fluorinated gases. Yeah, some fluorinated gases. All these are primary greenhouse gases. They form from like CO2 forming from fossil fuel combustion and deforestation. How does it form? Fossil fuel combustion and deforestation, right? Methane is released from agricultural waste, or decomposition of industrial processes also. Then natural gas leaks, agriculture, livestock, landfills, all of them release methane or CH4. N2O from industrial releases. And the fluorinated gases coming from man-made HFCs, CFCs, PFCs, hydrofluorocarbon, all these used in refrigeration, air conditioners, they're all responsible for this. They're all responsible for the greenhouse effect, and they all constitute as a part of it, right? So we have to tackle these primary greenhouse gases, and we have to make sure that they don't bring that effect to the environment. Clear? Then we have the global warming potential gases. Okay, we have the global warming potential gases. The global warming potential gases. These are the measure that is measuring or comparing how much heat a gas traps, right? Relativity, like which of them would trap heat more, right? That is the study of global warming potential. For example, methane has much higher GWP than CO2, right? GWP than CO2, but it remains in the environment for a very short time. It gets decimated because it is not a stable compound. It gets reacted with something or the other and forms new bonds and gets decimated. However, CO2 remains in the environment for a very, very long time. Yeah, that is, it remains in the environment and keeps trapping heat. Okay, yeah. Let's understand what greenhouse effect is. Through this image. We have sun. Sun is giving us heat. Yeah. What is sun giving us? Sun is giving us heat. Now, while that heat reaches Earth, some of the sunlight is absorbed at the surface. Yeah. Some of the sunlight is absorbed. Some of the sunlight is reflected by the surface. Now, some heat that is absorbed, right? We have CFCs, etc. released from here, from aeroplanes, nitrous oxide from all the vehicles. We have methane from the cattle, carbon dioxide from the oil, coal. All these human activities release greenhouse gases. Yes. Now, all the heat that was to be reflected back, this heat that was to be reflected back, while getting reflected back, gets trapped by the greenhouse gases. It was supposed to go back, but instead of going back, it just stays there and keeps revolving with the greenhouse gases. Because of this, the temperature rises. Because of this, the temperature rises. Yeah, is that clear? Yeah, this is greenhouse effect. This creates a sort of greenhouse where nothing is escaping. All right. Some of them has gone through atmosphere, some have been absorbed, some were supposed to be reflected, but this disturbs the entire heat budget of Earth that needs to be maintained for life to sustain. That's why at this time you see this is India's hottest year. Yes, hottest year with El Nino. Just imagine we have the hottest year that is also with El Nino, right? The hottest year with El Nino, that is how the condition is going to be. This is because of all this climatic change that has been brought down by the greenhouse effect. And if we talk about the contribution, we have CO2 76%, longest lived baseline. Methane 16% in the environment, highest, high GWP. Nitrous oxide 6% and fluorinated gases 2%. This is the current composition. Now, because of all this, it leads to ozone depletion. What is ozone? Ozone is a layer that protects us from UV rays. It protects us from the sun heat, right? It helps maintain the heat budget as well. A protective layer of Earth. Okay. Now, this ozone layer is, the composition of this ozone layer is O3. Okay, when CO2 is released, what happens is, just understand, for oxygen forming a bond, oxygen is most stable in its O2 form, right? Any atom, any molecule tries to obtain its most stable form. They will keep reacting here and there until they are in their most stable form, and then they will keep resting. So oxygen always tries to get into O2 form. Okay, that is its trial. Now here it is CO2. So naturally it wants to release carbon and react. Since there is O3, this O3 plus CO2 will react and form carbon monoxide plus 2 molecules of O2. How so? This CO2 is going to break down. This is CO and O, carbon, oxygen and oxygen. This will form carbon monoxide and this oxygen will be free. It will react with O3. It has 3 molecules. It will give 1 molecule to, 1 atom to this oxygen. This becomes O2 and O2. Now they are stable. They don't want to react any further. CO2 is not harmful. This carbon monoxide thus formed is harmful. Why? Because this O3 molecule is breaking down. This entire layer is formed of multiple O3 molecules. Multiple O3 molecules. That is how the layer is formed. If we keep pulling out each O3 and we keep framing O2 and O2, this will break down. Naturally, you pull out 1 molecule, fine, not that visible. Then you pull out 2, 3, and like this, a multiple segment of oxygen has been pulled out. And that creates a hole in the ozone layer. The oxygen molecules have been taken out from a place and there is a hole now. Right? O3 came, reacted with CO2, became O2, went away. Then O3 came, CO2 came, reacted, O2 went away. Like that, O3 comes, reacts with CO2, frames O2 and O2 and done. Right? So what are we to do with this? Because this will keep depleting our ozone layers. right? It will keep depleting our ozone layer. So that way we will never have a stable ozone layer. That is called ozone depletion. This whole process is what? Ozone depletion. You understand that? Yes. Now this can be done not just through CO2, this can be done through CFCs as well, chlorofluorocarbons as well, like ozone depleting substances like chlorofluorocarbons, halones, all these do the same thing. I've just explained you one process. All of them do the same thing. They break the O3 molecule to form a more stable compound. That way, it never turns back into O3. It never turns back into O3. Right? Destroys the ozone molecule, destroys the ozone membrane. Clear? This will lead to increased UV radiation, skin cancer, cataracts, marine ecosystem is going to die. All these things will happen just because ozone layer has been depleted, and this will, there is a hole in it, UV radiations are coming, and all this will happen, skin cancer and whatnot. And the heating up of Earth, obviously, that is still going to happen. The heating of the Earth is like something we cannot get rid of. Something we cannot get rid of, right? So for resolving this issue, we've come up with multiple conventions, agreements, protocols, etc. So that we can deal with this. We release less carbon dioxide. We capture the carbon dioxide even if it is released, so that it doesn't reach, a lot of it doesn't reach the ozone layer, and we are able to preserve the ozone layer, right? We have been doing that, and for that we've come up with Montreal Protocol as well. Yes, for that we've come up with Montreal Protocol, and in that we have Kigali Amendment as well. What is Montreal Protocol? Let's try to understand that. Montreal Protocol is the most successful environmental treaty in the history. Okay. We call it the most successful environmental treaty in the history. Why do we do that? Understand? This was done in 1987. Okay. Done in 1987, global pact to phase out CFCs. This was a global pact that we will phase out CFCs. Carbon dioxide is very difficult to phase out because it is a part and parcel of life. The mere existence of human beings is equal to carbon dioxide. How do we eliminate that? So we chose CFCs. They are also a huge party to this. So we will, phase out the production of CFCs and will shift to better. Yes, we'll shift to better things. Yeah. So we tried to phase out, but it was not possible. We came up with even worse alternatives. So then came the Kigali Amendment. Through the Kigali Amendment, this happened in 2016. Okay. This happened in 2016. Through Kigali Amendment, what did we decide? That protocol targeted HFCs now. Why? Because to get rid of CFCs, we came up with HFCs or HCFCs. Hydrofluorocarbon or hydrochlorofluorocarbon. We wanted to get rid of chlorofluorocarbon. We created hydrochlorofluorocarbon and hydrofluorocarbon. Right? This led to even further depletion of ozone layer, even further dangerous than CFC. So this was like, okay, we have done something bad. Let's make this right before it just kills the whole mankind. Let's come to senses. Okay. So we were able to realize that, oh, we've done a blunder. We've done a disaster. Let's amend this. Then came the Kigali Amendment 2016. There we said that targeting HFCs, all kinds of HFCs will be targeted here. Okay. So we now need to get rid of this. Why? HFCs do not deplete the ozone layer. Just remember that. HFCs do not deplete the ozone layer. Then why are they stressed? Why are they a problem then? They were safe replacement. Actually, they were safe. When we replaced CFCs with HFCs, it was safe. They don't deplete the ozone layer. Then what is the problem? The only problem that came with that was this was a greenhouse gas. This was a greenhouse gas that was leading to very, very, very fast rise in the temperature of Earth. Just by eliminating HFCs since 2016, world can avoid up to 0.5 degree of warming. Just by stopping the use of this, 0.5 degree of warming can avoided by 2100. By the year 2100, we will be able to avoid 0.5 degree of warming up of the earth just by stopping the use of HFCs. Just by phasing them out. That's how serious it was. Sorry. You understand that? This was our Montreal Protocol and Kigali Amendment. Okay. Yeah. Moving on to Paris Agreement. Paris Agreement that was done in 2015. We know that, right? Paris Agreement is not that old. So most of us are very familiar with it. Why was this important? Legally binding. This one was legally binding. Landmark legally binding international treaty on climate change. Right? Legally binding international treaty on climate change. First of its kind. What was the goal? To limit global warming. Goal was set that we will limit our global warming. To what limit? Below 2 degrees Celsius. Well below 2 degrees Celsius. Okay. Preferably to 1.5. Preferably, we want to reach to 1.5 degrees Celsius. Not just 2, preferably we want to reach to 1.5 degrees Celsius. Okay. But how? What is the reference point? Compared to pre-industrial levels. Pre-industrial levels. Yeah. When industrialization hadn't begun, at that point, what the condition of environment was, that is taken as a reference point. Okay. Under this, we've been asked to sign NDCs. What is NDCs? Nationally determined contributions. Nationally determined contributions. Why did the idea come up? Why is it nationally determined and not internationally determined while the agreement is international and legally binding? Why is it not internationally? See, what happened was this led to a fight. Here came a concept, common but differentiated responsibility. This led to a fight between the developing and developed nations. Okay, between the developing and developed nations. What was the fight? Developing nations said that developed nations have caused the maximum rise in the temperature. Yes, because we are still developing. You have already done that. So naturally, your share in increasing the temperature is much higher than our share. Simple. Developing nation says to developed nations that our share in increasing the temperature of the earth is far lower as compared to you. Because you have done all your development, infrastructure, construction, industrial, all kinds of development. Now it is our chance. Now while we are trying to develop, you are saying that we should not develop because it harms the environment. When you were the one who harmed the environment, whose responsibility should it be to take care of the environment, to repair it, to put the cost of environment reparation at bay? Whose responsibility should it be? Should it be ours or should it be yours? Right? So now technically we cannot say that all the responsibility lies on developed nations also, because developing nations are working towards it. So naturally we have to take responsibility also, right? So with this we came up with the concept that okay, we have a common responsibility of saving the earth. Right? Why? Because Earth is common. When Earth starts to boil up with heat, it will not see whether it is developed nations area or developing nations area. It will just burst out, right? It won't come and knock and see, hello, is this developing nation? Okay, I'm going. Hello, is this developed nations? Okay, I'm coming, right? Yeah, when Earth or volcanoes start to blow up, they won't ask this. They will just blow up because Earth is getting heated up. No matter who did it, entire Earth is getting heated up. It will affect everybody. So naturally, developing or developed, we all have common responsibilities, but the responsibility is still differentiated. It is still differentiated. Why? Because the role of developed nations was much higher than developing nations. So the cost bearing should also be higher, right? That's why the responsibility is differentiated. So nationally determined contributions will come. A nation itself will decide what kind of contribution it thinks it can give, and that only should be their standard. That only should be followed. Clear? Understood? That is the concept of NDCs and CBDR. Yes, so every country will set their voluntary targets. Every country has voluntary targets. You know where we want to go. This is the goal. So you set your targets accordingly. You try to meet them. That's all. Yeah. NDCs and CBDR. Concept clear? Absolutely clear? Okay. So this comes up with what we will do. We will have a periodic review of how the nations are doing. How each nation is doing on their voluntary target. We'll have a periodic review and see how far we are from the 1.5 degree goal. Clear? Is that clear? All right. Coming on to next, what did India adopt then? India took a net zero target. India wants to become a net zero emission country. NDC of India, what is India's commitment? To be a net zero emission country by 2070. By 2070. Right? That is our Panchamrit plan. For this, it is our Panchamrit plan. What is our Panchamrit plan? To achieve this by 2017. Net zero. Now understand, does net zero mean zero emission? Does net zero mean zero emission? In statements, it is generally given that India will become a net zero emission country. Does net zero emission mean zero emission? No emission at all. Is that even possible? Just think about it. Plants, human, animal, as long as they are alive, is net zero emission possible? We will be inhaling oxygen, we will be giving out carbon dioxide. How will we live otherwise? And if we don't leave out carbon dioxide, what happens? And if we are leaving carbon dioxide, naturally there is a release. Naturally there is a release. And no matter if, even if we try to control anything and everything, the area around us is not going to allow us to manage the heat and the earth and the sun, everything now can be. So net zero is possible, but not zero emission. So this does not mean that the emission will be zero, the net will be zero. How it will be zero? Because we will be trading off carbon credits. We will be trading off carbon credits. How we will do that? We'll talk about it in the carbon market. We'll do a topic carbon market. We will do in that carbon finance or carbon market. We'll do in that. Okay. So let's put a pin onto this and move forward. That this does not mean, it is just that a state of balance where the amount of gases produced will also be removed. That's it. Right? Yeah. That is our Panchamrit plan. India's strategy, non-fossil energy capacity. What are other targets? Non-fossil energy capacity. 500 gigawatt by 2030. Let me tell you, this has already been achieved in 2025. We have already achieved this. 2025, we have already achieved this 500 gigawatt target. Second, meeting 50% of energy requirement. Meeting 50% of energy requirement through renewable energy by 2030. This we are doing. The problem is we have created energy, but we don't have the infrastructure to actually start utilizing that energy. So we are storing it for now through BESS. You know BESS, right? Battery Energy Storage System produced by India. We are storing it there. We will use it by 2030. We will create that infrastructure for this to be used. Yeah. Yeah. Then reducing total projected carbon emission. Reducing our total projected carbon emission. What was the total projection? Right now we discussed what is the total projection. We will be reducing by 1 billion ton. 1 billion ton. That is also by 2030. How will we achieve this? By using this 500 gigawatt. Simple. Simple as that. Then reducing carbon intensity of the economy. Reducing carbon intensity of the economy. How much do we want to reduce that? Do we have carbon intensity in the economy? Yes. Most of the things in economy are run by carbon. Most of the things use carbon, release carbon, have something to do with carbon. So we will be, doing that, reducing that by less than 45%. By less than 45%. Like less than 45% of our economy will be carbon dependent. Right? These are our targets, India's net zero targets, India's NDCs, India's vision. Clear? Yeah? Okay. Absolutely clear? Fine. This brings us to climate finance. Carbon finance. We put a pin there. It's time to take that pin out. Let's move to our climate finance or carbon finance. Okay. We have carbon markets. What is climate financing? We have created a financial structure where we are running a market of carbon. We are running a market of stabilizing the climate. How do we do that? Climate is affected by carbon release. Yes, climate is majorly affected by carbon release. If your carbon release is higher, naturally your climate finance is low. Yes. So we have created carbon markets. How do carbon markets work? Let's understand that. What is climate financing? Marketizing carbon emissions. How do we do that? We trade off. What do we trade off? The loss or gain of carbon. The loss or gain of carbon emission. How do we do that? By creating carbon market. By creating carbon market. What is carbon market? Try to understand. Suppose India has been given a limit that you can emit 100 units of carbon. Okay. India has been given a limit that according to current scenario, you can emit 100 units of carbon. India only emitted 80 units. India only emitted 80 units. So 20 is surplus. 20 is surplus. Yes. On the other hand, China was given a target that you can only emit 100 units. Okay. 100 units of carbon. They emitted 120 units. They are in 20 deficit. Yes, they are in 20 units deficit. What India will do is, India will give their 20 unit surplus to China at a price. at a pre-decided price, we will give our 20 unit surplus to China. They will still be able to do 120, but at this additional price. We will sell off our 20 surplus units to China. Have we traded off our carbon, our emission? Yes. This is carbon market. Any industry, any individual, anybody. You see, these days, many Gen Zs are just, many of the adults are just, youngsters, not adults. Youngsters are getting into these industries of renewable energy, waste management. It is not the money of the waste management that they're seeking. It is the collection of carbon sequestration units. Those units will be sold internationally at a very high price. That is the real game. That is the real business. Okay, that is what they're doing. So this is carbon market. Do you understand that? There are many enlistings. There are multiple websites where people list out that I have these many carbon credits. You can take that because we have carbon credit. Do we have that? And China has carbon deficit. We pay for that. We earn and they get their certificates. Right? If we sell this certificate to them, their capacity will become 120, which meets their emission. Understood? That is climate financing and carbon market. Okay, carbon credit and compliance market. This is actually regulated. This is not black marketing. This is regulated by government agencies because international platforms allow this. Okay, this is regulated by government agencies. This is very legal. Voluntary, yes, because businesses can buy credit, offset their emissions voluntarily. That is up to them. Totally voluntary. Okay. Understood carbon market? Yeah. How does this work? It works on the basis of carbon capture and storage also. Yes. There's another concept that if you don't want to do this, you capture carbon and you store the carbon. Yeah. This is a technology. The technology of CCS that can help us capture 90% of the carbon. That will help us capture 90% of the CO2 emissions produced by the use of fossil fuels. We'll capture this. That has been produced, 90% of the CO2 produced during fossil fuel, electricity or industrial processes. Yes, we will be able to capture that. And that sequestration, how does it work? Just take a look. What happens is, let's say these industries are releasing carbon. Okay, they are diffusing carbon, dispersing carbon dioxide. Trees will be able to catch that. We just discussed, trees have the power of carbon sequestration. They can take back the carbon from the environment. So trees will capture that. Yes. Yeah. Okay. So from here, where will we go? From here, where will we go? Instead of letting them emit, here we will attach a small plant that will be able to capture and separate the CO2. Okay. Now, if they capture, the soil amendments will happen here. We will add, right? And if we add it here, the whole CO2 is infected artificially internally in the coal mines or reservoirs. It is never allowed to see the light of the day. It will never go into the environment. Either we can add it into the soil or we can get it into the pipelines, and through this there will be stored into coal mines, depleted gas reservoirs, deep aquifers. It will be buried deep inside the earth, right? It will never see the light of the environment. That is carbon sequestration. Or if you don't want to put it inside the earth, you can store it in the cylinders or somewhere, right? And then break down the gases and use in different forms. Whatever, but don't let it go released. That's it. That's the whole concept. Don't let it get released. Clear? Carbon separating CO2 from other gases, then transportation, then storage. These are the 3 steps. Clear? Do you understand carbon sequestration now? Moving on to India's policy framework for this, we have an NAPCC, that is on the national level. Okay, that was launched in 2008. It has 8 core missions: solar mission for enhanced energy efficiency, etc., etc. SAPCC, state level, specific regional structures. Yeah. Example, Rajasthan's SAPCC focuses on desertification, water scarcity. Now, every state doesn't need to focus on desertification, do they? So, they're very specialized according to the region and their problems. Clear? Yeah. These are the frameworks that we have. Clear? Exactly. Coming on to the next thing. To cope up with the NDCs, on the national level, we have come up with SDGs, 17 SDG goals, so that we are able to fulfill our NDCs. To fulfill NDCs, we've broken them down into 17 sustainable development goals. Yes, this has been adopted by UN. Okay, this has been adopted by UN in 2015. How many goals are there? 17 goals are there that will help every country achieve their NDC targets. Yes. They are to be achieved by 2030. All of them are to be achieved by 2030. Yes? Yeah. Now see, the beautiful thing is that they don't just focus on environment. They also talk about poverty. They believe that all these things, poverty, environment, they should all go hand in hand. Only then we will be able to tackle this problem. Let's say there is poverty, people will use local kerosenes and whatnot as cooking oil or as diesels for their vehicles. They will keep using that. They have cheap access to that. They will always keep using that, and we will never be able to eliminate their use because there is poverty. So they all go hand in hand, and we have to realize that it is not just about environment, but the entire lifestyle of the country. Right? Yeah. Is that clear? So these are our sustainable development goals. Multiple goals are there, 17 goals, talking about different things like poverty, environment, affordable clean energy, climate action, life below water, life on land, all these things. Clear? Next is mission life. That is lifestyle for environment. That is necessary, that we just talked about. That environmental change is not just about creating rules and eliminating gases. It is about creating a proper lifestyle, right? A proper lifestyle is required to change that. This has been introduced by India at COP26. India introduced this at COP26, that is Mission Life. That says that you shift your focus from policy level change, shifting focus from policy level change to individual action. Right? That is required, that individual action is required. Every individual should understand the implication of their action, their lifestyle, their day-to-day activities on environment. And that individual action needs to change. Everybody should change their habits, and that is how the nation is going to change. Right? Yeah. So we need to definitely eliminate the use and dispose culture. The use and dispose culture that is effluently leading to greenhouse gases, plastic release, etc. This should be replaced with circular economy. This should be replaced with circular economy. Is that clear? Yeah. What is circular economy? Where everything keeps getting recycled, reused. That is circular economy. Yeah. And not just that, even the currency is coming back to you. The currency, the money for it is also coming back to you. Right? Yeah. How do we do this? We need pro-planet people. We need pro-planet people, that is 3P or P3. Okay, that is P3. Movement is like you create a global network of individuals. This should be a global network where people will come together, like-minded people who want to preserve environment, who are active there. They will come together and spread awareness, show their lifestyle practices, and will treat everybody else in a manner that they need to promote environmentally friendly lifestyles, right? Promoting environment friendly lifestyle. That will be their task. That will be their task. Clear? Is that clear? Yes? Yeah. Saving energy at home, reducing single-use plastic, adopting sustainable food systems, all these things are to be implemented. Clear? Yeah. This was our topic of environmental institutions, climate financing. Yeah, climate financing. Is that clear? All right. Moving on to our next topic, that is environmental impact assessment. Now, there has been an impact on the environment already. We are trying to reduce that impact as well. But the kind of impact that has already been created and is being continuously created, we need to evaluate that first, get their data, assess what the impact has been, and then act accordingly, create policies accordingly, right? Do you agree? That is our environmental impact assessment. That is our environmental impact assessment. Okay, so how are we going to do that? Like, because obviously this will become our decision making tool. This will become our decision making tool to ultimately decide what kind of structure we want to create, right? What kind of structure we want to create, what kind of environmental consequences we can expect, right? What kind of environmental consequences we can expect from the actions we are taking, what consequences will follow. Then, then they will ensure potential problems, they can be addressed before everything begins. Address the issues before the project, not after the project, right? Whatever we are doing, you analyze, you address the issues before the project, right? How does the project work? How does the project work? You are starting, let's say, a project A, okay? You need to assess everything. You need to screen, first of all, environmentally screen, like what project needs on the environmental impact basis. See the scope at which environmental issues can be your concern. Then you will see impact analysis, like to what extent you will be able to deal with this impact analysis. Once you've done impact analysis, there will be a public hearing, whether public agrees with it. Okay, and then the final decision will be made. Environmental clearance will be given. Screening, scoping, impact analysis, public hearing, and the final decision by environmental clearance bodies. Yeah, that is our environmental impact assessment. How is this done? We have certain procedures and rules established. Okay, we have certain procedures and rules established under which we are doing all this. We had 2006 and EIA 2006. Now we have EIA 2020. Okay, let's see a comparison. Post facto clearance, in terms of post facto clearance, 2006 structure, the old structure, 2006 structure, it did not allow projects without clearance were illegal. Yeah, post facto clearance is not allowed. Now it is allowed in regularization of projects that started without clearance. You can pay a fine, but you can continue the project, right? So this goes both way. Like, it won't hamper the development, but it will still give you the chance to find a loophole, right? In terms of public consultation, EI is done 30 days are allowed for public to submit responses. Here it has been reduced to 20 days because you need to fasten up the process. Growth is depending upon this, right? Not everybody is trying to get away with environmental impact. Exemptions, large projects required public hearings. Here, many projects like strategic borders, small mines, they are exempted. Like, even if they come to their full potential of carbon exploitation, environment exploitation, still they won't reach the limit. That's how small the projects are. Why delay them? Just let them go. Okay. Then we have reporting. Compliance reports are submitted every 6 months that we are complying with everything. Just check this. We have done everything. Here they are submitted once a year. That is enough. If you're doing everything fine, once a year report would be enough. Not every 6 months. Yeah. They've eased out the rules. This is a part of ease of doing business. Yeah. This is a part of ease of doing business. Clear? Yeah. We are still doing everything, just making the process a little bit easy and breathable, right? We're not killing our industries. We're not killing our startups. We're not killing our investors. That's all. Clear? Yeah. This is regarding the regulation of the projects. Another thing we need is the regulation of coastal zones. Another thing we need is coastal regulation zones. Yeah. Regulation is required because another large scale pollution happens here. Another large scale pollution. So India has a huge coastline. Yes. So government created CRZ rules to protect this coastline. Clear? Yeah. Now for protecting this, what CRZ does is, the CRZ rules help us maintain the coastal zones according to their requirements. Yeah, because they have a fragile shore ecosystem. So there should be no unregulated constructions, no pollution, right? Now you cannot go and set up a factory at the shore, right? Yeah, there's beach that is fine. There are cafes that are fine, but beyond that, no. Right? And another thing, it is necessary for protection also because most of them come under high tide line. If they come under high tide line, they are prone to flooding. If they are prone to flooding, they are anyway not safe for construction. Right? Even human activities should be limited there. So for regulating all this, to make sure environment is also protected, humans are also protected, illegal constructions are not happening, we are not exploiting the area, aquatic lifestyle is also, sorry, aquatic system is also protected. To ensure all that, government has come up with CRZ rules. Under the CRZ rules, government has divided the entire Indian coastal zone, the entire Indian coastal line, or the coastal zone into various categories. Okay, we have 4 CRZs. CRZ 1 to 4, under which different areas are regulated in different conditions. How so? Just take a look at this. CRZ 1, ecologically sensitive areas like mangroves, etc. No construction allowed. Highest protection is given to CRZ 1. CRZ 2, development areas like coastal cities, Mumbai, Chennai, they've already developed. What will you do? Construction is allowed, but very regulated. Okay. CRZ 3, rural areas, relatively undisturbed. So no development zone. There should be no development here. Limited tourism is allowed. For tourism, the basic needs and facilities can be created. But other than that, nothing. Nothing. No development zone, NDZ. CRZ 4, water area, shore up to 12 nautical miles. From shore to 12 nautical miles, that is our water. Personally our water, right? Up anyway, country has till 200 nautical miles, right? Country has till 200 nautical miles, but 12 is very personal. Till 200, it is like shared capacity for trade, etc. Yeah. So till 12, it is like we can regulate fishing, prevent water dumping, all these things. Yeah, these are the 4 CRZs and how we are regulating it. Clear? EIA works on it, CRZ also works on it. This is how CRZs are governed. Moving on to our next topic, that is renewable and alternative energy. Now, to prevent all this pollution, to maintain all this, we definitely need better sources of energy. We've anyway had 500 gigawatt target, right? So what are these energies? What kind of energies are we looking at, and how are they important? And where India stands in this? Let's see that. Renewable energy and alternative energy. Okay. In terms of renewable and alternative energy, what you've seen is that this is the transition to cleaner energy. Yeah. What we are doing, transitioning, where we are transitioning to cleaner energy. What is cleaner energy? Cleaner energy means that doesn't impact the environment adversely. That is clean for us. Simple. Environment or organisms are not impacted adversely. That is clean for us. So we are moving towards cleaner energy. What cleaner energy are we looking forward to in India? Yes. So this is like moving away from fossil fuel towards a hydrogen economy. Okay. We also say that we are moving away from fossil fuel to hydrogen economy. What kind of hydrogen economy are we trying to establish here? The kind of hydrogen economy we are looking at is optimizing fuel sources through biofuels. For fuel, we are shifting to biofuels, right? Ensuring buildings we live in, energy efficient, ECBC codes. For energy, we have ECBC codes building, right? Energy efficient buildings. How do we do that? We do that through renewable and alternative energy. Traditional renewable energies are also there. Traditional renewable energies like solar energy, wind energy, right? Wind, hydro, geothermal. All these are traditional renewable. Not traditional, traditional renewable. The ones we have been studying in NCERTs since we were also in 5th, 6th standards, right? And even the generations before us have read about them in NCERTs. So they are very traditional. Now world has come up with new kinds of renewable energies, right? Solar and wind is there. Solar and wind, 500 gigawatt we've already achieved. Geothermal, tidal wave, small hydro energy. These are the renewable alternatives, right? But above all this comes biofuels. Biofuels, liquid or gaseous fuels. That is liquid or gaseous fuels. Why are they being created? They are produced from biomass. Biomass, that is completely organic matter. Completely organic matter. Yeah? Yes. Now they are categorized by generations. They have categories on the forms of purity, utility, etc. They have categories that they are divided into. Okay. Yeah. How? By generations. They're divided by generations depending on their purity, etc. What generations do we have? First generation from edible food crops like sugar, corn, vegetable, etc. Very easy to produce, completely aligning with the food security. But it also sometimes competes with food security. We don't have enough to serve our people. We are crushing it to form fuel. That is difficult. Second gen, non-edible waste. Rice straw, corn cobs, wood chips. This is non-edible, so not competing with food security. But it solves the food versus fuel debate, but this is very harder to process. Right? It is harder to process. Then we have third gen, specially engineered algae. Specially engineered algae, high yield, can grow in wastewater, salt water, anywhere. So this has become very important these days. Then we have fourth gen, genetically modified crops, right? This is designed to be carbon negative, right? How is it carbon negative? It is basically designed by capturing CO2 as they grow, right? When they grow, the crops that they are growing, they will capture CO2. the crops while they are growing, they're carbon negative. That means they will never release carbon, but they will always capture carbon. Yeah, they will not release carbon, but they will always capture carbon. That's how they are carbon negative. Just imagine something being carbon negative. How wonderful is that? That's why they are very popular these days. No doubt they're popular. Biofuels, carbon negative crops. Amazing, right? Amazing. Yeah. So these are our biofuels. We have national policy on biofuels also. To manage them, we have a national policy on biofuels. Okay, we have a national policy on biofuels that aims for a 20% blending of ethanol. Because of this ethanol blending, because of this we are continuously seeing a rise in ethanol blending in petrol by 25-26 E20 target. This is called E20 target, and right now we are moving towards this. Yes, clear? Clear? All right, moving on to hydrogen economy. Moving on, what is hydrogen economy? Simply a future where hydrogen is going to play a major role. Yeah, where hydrogen, that is H2, is the primary fuel that has become a primary fuel for transport. It has become primary fuel for transport, heating, industrial purposes. Everything is running through hydrogen. This will be hydrogen economy. Simple. Because hydrogen is anywhere engine carrier, right? So we don't have to do much anyway. This will be very fine for us. It has its own energy. It has its own energy. It is an energy carrier. It has its own energy and not a primary source. Like, yeah. And the color coding, we see green hydrogen, blue hydrogen. It is just how it is produced. Okay. The color coding that you see generally regarding hydrogen, that is how it is produced. Like green hydrogen, if we talk about, green hydrogen is simple. It is produced from natural gas, right? So green hydrogen, from methane and CO2 also. Okay. Yeah. From natural gas, that is methane, via steam reforming, releasing CO2. Then we have blue hydrogen. Blue hydrogen is formed from natural gas, but resulting CO2 is captured and stored. Framed from natural gas, and this CO2 is released and CO2 is captured. In blue hydrogen, we capture CO2. Okay. Then we have green hydrogen. This was gray. Then we have green hydrogen. Green hydrogen that is produced via electrolysis of water. This is produced from electrolysis of water. Understand that? This is produced by electrolysis of water using renewable energy. Water and renewable energy. Just imagine what a beautiful concept. What a beautiful concept. Where will you release carbon dioxide here? Where will you do that? Truly zero emission version. Where is CO2? Where will you release? Truly zero emission. Okay. Truly zero emission. Clear? Yeah. Now for this hydrogen economy, we also have a national green hydrogen mission. A national green hydrogen mission. Okay. We have such a mission through which what we are doing is we are becoming a global hub for the production of green hydrogen. We are trying to become a global hub for the production of green hydrogen. Clear? That is what India is trying to achieve through this mission, targeting 5 MMTs. Target is the production of 5 MMTs. What is MMT? Million metric ton per annum by 2030. This is not total. This is per annum by 2030. We will be able to produce 5 MMT per annum and will be able to trade it off. That will give us carbon credit. Then we'll do development. Yes, good maths. Good maths, right? This will give us carbon credits because we are producing hydrogen. We are trading it off. That is saving carbon emissions. So will give us, this is zero emission. Just imagine the level of carbon credits. Zero emission, right? So we'll have a lot of carbon credits. Then we'll be able to do a lot of development using those carbon credits. Clear? Moving on, we have ECBC. What is it? Energy Conservation Building Code. What is it? Energy Conservation Building Code. Now, buildings using massive chunk of electricity. Yeah. Massive chunk of electricity. Now, what you do is you create such buildings. ECBC sets minimum energy standards. This will set minimum energy standards, like at least this much should be conserved. They will set, this is done by Bureau of Energy Efficiency. By Bureau of Energy Efficiency, first of all, this is working under Ministry of Power. Working under Ministry of Power. Okay. Nextly, what is the target? Large commercial buildings with load of 100 kilowatts. Large commercial buildings with a load of 100 kilowatts. They will be targeted specifically. Now, since we are targeting them, we will have some parameters like wall, roof, window, lighting system, heating system, electric power system, everything. Right? So these energy conservation codes, they should go by new energy conservation. The new codes that have been released, Energy Conservation Amendment Act released in 2022. Amendment Act of 2022. That is how they will run, the basis of this. On the basis of this act has released Energy Conservation Sustainable Building Code that will include large residential buildings also. Yes. So this will include large residential buildings also, not just commercial. Because these days, because of the flat culture, we have very large buildings, right? So those large scale buildings also need to cater to this. Clear? Yes? Exactly. This is ECBC for you. All right? Yeah. Clear? Understood? Yeah? We're just understanding basics, because in environment, we've been consistently told that the basics are not clear. People are just, cramming up data, cramming up new schemes, that's all, cramming up the terms. They don't understand. So we're trying to teach you the basics so that you understand, like, basics of the topics that are repeatedly asked. So you understand the demand, you understand the basic concepts. So you are able to just read current affairs and everything additional that you read with ease, right? So I hope you're understanding the basic concept or the idea behind every terminology, every concept that has been generated. Yes? Yes? Okay. So next we are moving on to wildlife conservation projects. We are moving on to some facts like Ramsar sites, projects, facts. We'll do that quickly. We have various projects running around, Project Tiger, etc. Right? You read these projects. So we'll just take a look at those projects, very basic look, like what they are working at, what is their basic aim. That's it. Number one is Project Tiger, 1973, maintaining population of Bengal tigers, specifically Bengal tiger, which is our national animal as well. Yeah, in their natural habitat. In-situ conservation. In-situ conservation. This was managed by NTCA, National Tiger Conservation Authority, following the core buffer strategy. Yeah. Then we have Project Elephant of 1992, protecting elephant, their habitat, migratory corridors as well. This is important. Migratory corridors are also being protected They are focusing on reducing human-elephant conflict, which is very large because elephants are apparently used for recreational activities, entertainment, and children's parks, right? Everywhere. So that conflict needs to be reduced. So domestication of elephants is also something that we have to cater to. Project Snow Leopard 2009, conserving high altitude wildlife, right? Community-based approach where people have been called upon, local herders have been called upon to help us do this. Clear? Yes? Yeah. Along with that, we have another initiative that is M-Stripes. M-Stripes is the technological backbone, we'll say. What is this? This is our technological backbone in saving tigers. And especially maintaining their data, at least. If not saving, at least maintaining data. Okay. Why? This is a software-based monitoring system. Through software, we will monitor the tigers. Yeah. How will we do that? Across all tiger reserves, right? No specific zone. All tiger reserves blanketly. We will be catering to them. And how will it work? Forest guards will carry GPS-enabled mobile devices. Okay. How does it work? Forest guard is there. He will carry a GPS mobile service while patrolling. Okay. They record the sightings of tiger, prey, or any sign of illegal activity. Through this, they'll record either they visit tiger, or they see a prey, or they see any illegal activity. Everything will be recorded. And since it is GPS, through that record, authorities will be able to find the location and reach there very quickly. Immediately they see the location and they reach. Right? This is intensive protection. Every square inch of the reserve is patrolled. You can track guards also. This will also be used to track guards whether they are patrolling every inch or not. Right? So this is very intense protection. Right? They'll give all India estimation also for ecological status, right? Yeah. Clear? This is M-Stripes software. Clear? Then we have eGreen Watch. This is also web-based portal. This is a web-based portal. What is it trying to do? Portal designed to bring transparency of compensatory afforestation. Transparency in compensatory afforestation. What is compensatory afforestation? Let's say we have to clear this land. There is this land. It has forest plantations. We need to clear this for development or for whatever reason. If we get a clearance, we promise that the same amount of the metric ton, we'll measure this in metric tons, and the same amount of forest will be planted on another land. We will bear the environmental cost. This is our environmental cost of development. We will bear the environmental cost, plant the same amount of forest somewhere else in some other land that is given to us, let's say on a highway or somewhere, and that way we will be doing compensatory afforestation. We are doing afforestation, but not out of the goodness of our heart. Right? It is not like, oh, our heart is melting, seeing the earth getting so hot. Let's plant trees. No. Humans are not that good. Right? So this is just because we want to compensate for the deforestation that we have done. So that is the compensatory afforestation. Now people say they will do it, but have they done it? That is very difficult to check. Right? Let's suppose I bought 4 lands. Okay. And 4 of the forests were cut. I planted one. When the team from A land came, I showed them this. When B land came, again I showed them this. C land came again. D land came again. Everybody thinks I have this chunk of land and forest. Yes, I do, but just 1, not 4. You understand how people are playing? So this should not happen, and to get a better management and monitoring of this, we've come up with eGreen Watch. Right? When forest is diverted, agencies, they say that you can do compensatory afforestation, but the problem is that nobody does it. Right? Nobody does it. eGreen Watch will use remote sensing and GIS. through remote sensing plus GIS, what they will do is technology will be used to monitor the new plantations, right? Yeah. But that's the CAMPA, Compensatory Afforestation Fund. Compensatory Afforestation Fund Management and Planning Authority. Compensatory Afforestation Fund Management and Planning Committee. Planning Authority, sorry. And Planning Authority. This authority's work is made so easy now because they had to go everywhere and check the land and do this. Now they will be able to track whether the trees were paid for, that are paid for, are actually being planted, whether are they surviving, are they taken care of, or they just planted it and left, right? So all these things are monitored by CAMPA. Who does that? CAMPA. Clear? This is E-Green Watch for you. Clear? Yeah. This was our projects, the projects that we have taken up to preserve environment, to preserve biodiversity. Next project, that is Ramsar Convention. Ramsar Convention that basically began in Iran. Ramsar is the place there. There was a convention held for the protection of wetlands, since they are very important to the environment. We came up with the wetland protection area. Yeah. Okay. So all in all, we have 99 additions to the Ramsar sites so far. 1971 Ramsar Convention that took place. Intergovernmental treaty. This is an intergovernmental treaty. Okay. That treaty helps us protect wetlands. Intergovernmental treaty that helps us protect wetlands and has been in force since 1975. It came in force in 1975, and wise use of wetlands, celebrating World Wetland Day on February 2nd. This is also their decision. February 2nd will be World Wetland Day. Okay. Yeah. So what we need to know here is, what are the recent additions to the World Wetland structures. Yeah. The recent additions, we have a tool, a project like M-Stripes. We've done this already, right? Green Watch and Project Tiger. Okay. Yeah. Let's see at the sites that we have. Since 2026 April, the last one was Shekha Jheel Bird Sanctuary in Uttar Pradesh, 99th site, located in Aligarh. Why is it important? Himalayan migratory birds, right? It is important because of the Himalayan migratory birds. Okay. Next one is 2026 Patna Bird Sanctuary, again UP, located in Etaha district. Despite the name, it is in the UP, not Bihar. Please remember that. The name is Patna, but it is in UP, not Bihar. This is where UPSC will confuse you. Can you see that? Can you see the point of confusion? Patna, you'll see, oh, so simple, Bihar. UPSC will be like, so simple, negative marking. Right? Don't do that. 2026, we have Charidhan, Gujarat, Bunny Grasslands, critical seasonal wetland. 2025, Silicate Lake, Rajasthan, located in Alwar. Why is it important? Vital water source near Sariska Tiger Reserve. 2025, Kopra Reservoir, Chhattisgarh, first Ramsar site of Chhattisgarh. First Ramsar site located in Mahanadi River Basin. Please, this is again important. Okay. Then we have Shekha Jheel Bird Sanctuary, UP, 99th site. This we have done. Okay. Yeah, this one. The same one. Then we have one in Sikkim, first Ramsar site of Sikkim as well. This is a sacred lake. Okay. Then we have, the next one we have is Udhwa Lake Bird Sanctuary, Jharkhand, first Ramsar site of Jharkhand as well, on the banks of Ganga. Menar and Khinchan in Rajasthan. Menar is the bird village. Menar is known as the bird village. Word famous for demoiselle cranes. That's why. Then Gokul, Gogabeel and Udaipur Jheel all are in Bihar. Udaipur Jheel, you see the name, not Rajasthan, Bihar. Massive expansion of Bihar's network. Oxbow Lake has been included here. Okay, yeah. These are the Ramsar sites that have been included. Some important facts that I want to list. You can learn these. You can learn these, okay. Some important facts that I want to include here is the top 3 states. The top 3 states, that is number 1, Tamil Nadu with 20 sites. Highest in India. Okay. Number 1 is Tamil Nadu. Second is UP with 12 sites. Third position is shared by Punjab, Odisha and Bihar. Punjab, Odisha and Bihar. Okay. Punjab, Odisha and Bihar. They share the third position. They share the third position and with 6 sites each. 6 sites each. Okay. These are the top 3 sites. Okay. Chhattisgarh, Sikkim and Jharkhand have gotten first time. The sites have been added first time. Okay. Yeah. Largest site is Sundarbans. Another fact for you. Largest site is Sundarbans. And the smallest site is Vembanar Wetland Complex. Okay. Vembanar Wetland Complex. The irony is that it has complex in its name. Renuka Lake. Another one is Renuka Lake of Himachal Pradesh. Renuka Lake of Himachal Pradesh. Clear? Yeah. Another important concept of Ramsar sites is the Montreal record. Okay. The Montreal record, that is the reminder that only 2 Indian sites are in the Montreal record, which is wetlands that need excessive saving, wetlands that need excessive saving, right? Only 2 Indian sites are here, Kevla Dev National Park and Loktak Lake. Kevla Dev National Park and Loktak Lake. Okay. Loktak Lake. Chilika Lake was removed from this record in 2002. Please remember that. Chilika Lake removed in 2002. Okay. Chilika Lake removed in 2002 because it has been successfully restored, so it doesn't need protection anymore. And that's why it has been removed. Clear? This was our topic of environment. I hope you had fun learning it. Okay, these are the important topics, large list of important topics. I hope you had fun, a little bit of fun at least. Okay, so do revise this. I hope the important topics are clear. Some sample questions have also been discussed here. I hope that is also clear. All right. So that was all for the Score Booster series of environment. All right. See you again in the next series. Till then, keep studying, keep working hard. Okay. Keep revising, keep testing, do a lot of mock tests. All right. Thank you so much for joining in. All the best for your prelims 2026. Do well, break the records. Thank you.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.